explaining how we are converting or our journey from a unimodal system to a multimodal system. So I myself, Siddhartha Mukherjee, who is working in the NLU team of SRIB, as Praveen already mentioned, he is our head of NLU part. Under his guidance, we are working in NLU. Let us start. Yeah. So first to start with the introduction. So let me introduce about the technology and the team. Here we will discuss about the journey. So while looking at the paradigm, how the shift where user is interacting with the system, in 1980s, the revolution happened with the graphical user interface from a command line interface. Things evolved. The graphical user interface changed the paradigm of interaction between human to a machine. The evolution started. It took around 20 years when smartphone based, touch based UI, user interface, revolutionized this paradigm. Then slowly, we have emerged into the voice arena, where the interaction, the modality has given a new paradigm, that is voice. In 2011, voice started to become one of the most interesting paradigm where people can interact with the system. Let's look at the different other aspects with respect to voice user interface. When we see that the market analysis, we see that there is a huge growth potential in terms of business for voice assistants. So there are, if you see all companies, big companies, our competitors like Google, Amazon, Apple, Samsung, Microsoft, everybody is coming with a voice interactions. Every one of them has their different strategies and different strengths for penetrating into the voice assistant market. As you can see, the voice assistant market is predicted to have a 7.8 billion US dollar turnover in the year of 2023. We are very close to it. Let's look our team. The logo what you see is our Bixby logo. This is Samsung Bixby, which is available in various products of the Samsung. In the Bixby, where we are today, we have commercialized Bixby into Samsung flagship products, where Bixby is an assistant which is present in our phones, smartphones like Note 10, S20. Every flagship products what you see, we have our Bixby enabled with it. Now, if I look at the dimensionality, how we are progressing, there are three major dimensions where as a team we are growing. One of the most important dimension is itself natural language understanding, which has two different flavors. Definitely NLU, which is natural language understanding for device, as well as natural language understanding for cloud. We'll give a more details where exactly cloud and device, this subtle interfaces where what we think when it should be in a cloud, when it should be device in a subsequent phases of these presentations. And other extremely important dimension, which is one of the core of today's presentation, is multimodal. And definitely such a big paradigm, such an interesting technological area, if we have to grow, we need cutting edge research. So I will touch base upon all these three aspects in today's presentation. Let us go to a deep dive. Let's see how a voice assistant system works. So when I say voice assistant system, typically, as I mentioned, if you open Bixby and give a command that set an alarm for jogging for tomorrow morning 6 a.m., what exactly happens? So the voice packets initially is captured and given to ASR system, that is automatic speech recognition systems, who is primarily responsible for generating the text output. The text is then fed into the natural language understanding system, which finally predicts what is the action command to be executed. And the final action command gets executed and we see the output in our hand. For example, if I say, hey Bixby, turn on my Wi-Fi, automatically Wi-Fi gets turned on and I see the action. So the two major part, speech recognition system and natural language understanding system. Here in today's discussions, we will be more emphasizing on the natural language understanding system only. Let me go to the another detailing. Looking at the natural language understanding system of a voice assistant, if we see, this is the overall flow of a product. When we call our voice assistant, typically a voice assistant pipeline goes through these many components. Let me explain and give a touch upon them very briefly. When a user says some utterance, for example, text to mom, so first, the NLU platform, it goes to a module called domain classification, where domain classification's primary job is to identify which domain, that is, which application it is, whether it is a camera, whether it is a messaging or a email or reminder or calendar, things like that. Once this is identified, it goes to a designated intent classifier. That means for each domain, there are specific intent classifiers. We have intent classifiers for camera, we have separate intent classifier for messaging, separate intent classifier for calendar, and so on. The job of the intent classifier is to classify into all possible supported user intents. For example, whether when I see this particular message, text to mom, whether the user is willing to initiate a message, delete a message, or he wants the system to read out the message so that he can listen. These are different kinds of intents. So there is a lot of challenges involved. I will come there. One classifier, one intent classifier can have huge number of intents, and that itself is a challenge, that many number of classes as an output layer. I'll come there. Once it identifies that there is a certain intent, then the next activity, which is a very, very important activity, is to get the slots. For example, when I say that set an alarm for morning 6 a.m., so 6 a.m. is an important attribute which needs to be identified, then only the actual functioning of setting an alarm will be possible. That is done by the slot tagger module. Next, it goes to a planner, executor, and the dialogue management module. It's a very, very important module. Once the NLU components have identified domain, intent, and slot, then the major role comes for a planning and execution and dialogue management. Dialogue management can be involved in understanding various aspects. It can do information required, information retrieval. It can go for a clearing any disambiguation. It can engage the user with a dialogue and so on. For example, if I say call John, and there are multiple Johns in our phone which is available, so dialogue management can interact with the user to ask which particular John he is willing to initiate the call with. And finally, that command gets executed and the end user sees the flavor of a voice assistant. So this is the overview of an NLU inside a voice assistant, very bird's eye view of an NLU in a voice assistant system. Let me go to the second part where I will explain the challenges. So when I talk about challenges, this is primarily from a business point of view. As a business team, when we have to commercialize our products, there are a lot of challenges in terms of achieving the user's expectations. We should meet the user goal. So what kind of challenges come into the picture? What kind of design challenges, what kind of user experience challenges we need to deal with? First and most important, the behavior of the system. The behavior of the system, where there is always a challenge between the deterministic behavior and the generalized behavior. We expect any user, once a product is outside the market, out in the market, in the hands of our customer, then we expect that any way of utterance, whatever way it can be, for example, I cannot expect my user to always tell that set an alarm or create an alarm for morning. He can simply say, wake me up in the morning. So to understanding that, we need a generalization. And definitely, When a large class classifiers or the system we design for a large number of classes for classification and we adopt generalization, we actually fight with the deterministic behavior. And there are certain cases, I will explain them, where deterministic behavior is very, very, very important for a product. Otherwise, our customers, our end users will not be happy. So the most important aspect and the biggest challenge often designing such a system is a balance between a deterministic and a generalized behavior. Then comes an important aspect which I touch based in our initial slide, whether to cater for the user's most important question of privacy and personalization. To get a better business, if we give a personalized output from an NLU system, the business is more lucrative, business becomes attractive to the user. And at the same time, to give personalization, we need to look into users' data. And there comes the challenge of privacy. All of us might be very much aware there are a hell lot of talks on the internet about the challenges of privacy and personalization with respect to different big houses entire world. There comes the beauty. Being an OEM, Samsung being an OEM, we can leverage our device capabilities. So we jump into the solutions which is on device, where users' data will not go to the cloud. At the same time, entire functionality developing on device is also not very suitable. So a balance between on device as well as a cloud-based solution handling the privacy and personalization is an important challenge too. Next question is about scalability. This is about business. Any company, any business house, they start the business with a certain number of features, certain number of functionalities which user starts enjoying. To keep the business rolling, to keep the ball rolling, we need to accommodate more and more features in a very short span of time. This is one aspect where the number of features increases and your users get adopted to it. Secondly, every user has their own unique way of speaking, their own dialect, their own languages. Different geographies have a dominance of different languages, and different languages have different challenges. So scalability of a system, when we design an NLU system, we have to think of scalability in not only in terms first in terms of fast incorporation of features, also we should incorporate the design for scalability of language expansions. If I talk about Bixby, Bixby is expanded to many, many languages now, and we are expanding to various other languages. Currently, it supports US-based English, Great Britain-based English, it supports Korean and many other languages. So the design aspect, we should consider the language expansion is an important, very, very, very important part of it. There are different challenges in language expansion. Different countries have, even English, for example, have a different varieties, different flavors. Indian English is different compared to the US English. English in the Great Britain will be different from that. If I come to Indian languages, there are different other challenges of code mixing and code switching. So many challenges comes where in terms of scalability, we need to handle this. When we talk about behavior, privacy and personalization and scalability, next comes product adaptation. This is a unique for Samsung compared to any of our competitors. We are lucky enough to serve our customers with plethora of devices. We are OEM, we support, we sell mobile, we sell watch, smartwatches, TVs, digital appliances, and so on. Bixby is omnipresent in everywhere. Creating an omnipresent experience across all products is a challenge in terms of designing an uniform human computer interaction system, as well as we have to think of any component. Currently we are discussing about NLU so that it can easily adapt the requirement for mobile, TV, digital appliances, and so on. In future, we are expanding as a part of the business, we expand devices one after another. Onboarding a new device into the Bixby system, how easy it should be, that also is a challenge. So these are the four dimensions where the challenges comes into picture. This four dimension is a conglomeration of business as well as the technical challenges. Now let me come to the understand the impact of core important components. Couple of components. One of the component is domain prediction. So what is domain prediction? When I say domain prediction is the first component in the NLU, where given an utterance in a textual representation, it has to identify which domain it is. That means it can, so one mistake in the domain classifier will impact the entire product. If an utterance which is user intended for messaging goes to clock or alarm, that's a product level impact. It is business sensitive. And the biggest challenge in domain classifier is a large scale variance. To handle all these three things, we need to have a very strong rejection system in domain classifier. To explain that, for example, if somebody says, I want to suicide, and system says, okay, let me put a reminder for it, it's a disaster. As a product which is running there into the millions of users' hand, it's a disaster. It creates a product level impact. It's a business sensitive issue. And on the same time, we have to understand we have already gone for generalization where large number of utterances to be supported. In this case, to support such a specific cases, business critical cases, we need our system to be deterministic. Here comes the actual design call for a deterministic system as well as a generalized system. When I say the large scale variance, the third point under the domain prediction I mentioned as large scale variance. The large scale variance is, if I think for different, I take three application names which are very commonly used inside phone. There is a calendar, there is a reminder, and there is a clock application. Inside clock also there is wall clock, stopwatch, timer, and so on. If you think an utterance, for example, wake me up tomorrow morning 6 a.m., it can be pretty well be considered as a calendar reminder, or it can pretty well also be adapted as an alarm. User wants to set an alarm. So considering when we enable 70, 80, 100, 200 applications through a domain classification system, there will be a lot of class variance, very much close resilience across different classes. So that number of large class variance is a very important challenge for a domain prediction. When I say product level impact, domain classification being the first component, it has to understand which it can support, the system can support, and which it cannot support. That's why it should have a strong rejection, because if the domain classification fails, unsupported utterances goes to the downstream components of an NLU, then weird behavior can be expected from a system which is not acceptable by the user. Coming back to the next important aspect is intent and slot prediction. Domain was more of a product, and intent and slot predictions are more of an application level impact. That means when I have an application, so when a domain classifier performs perfectly, then the utterance goes for a particular domain's intent and slot prediction modules. So if any failure happens, that impact is an application level impact. Here, what will you have is much more close resemblance across different classes for an intent classification. Here, we need to have a very high recall to give a better user experience. In this case, when I say intent and slot prediction, it is a very much needed, very fast and easy deployment. When I think for a new intent to be added, I cannot expect it to take months. With a minimal number of utterances, from a very low resources, an intent prediction and a slot prediction module should be enabled. And definitely, we cannot rely complete rejection on part of a domain prediction system. There is a possibility, since it is an AI based system, there is a possibility that there is a propagation of error from in hierarchical system domain towards the intent, the error gets propagated. That's why even an intent prediction system, intent classification system should have a rejection mechanism, and we should have a clear rejection system which can tell whether this system is this utterance or this particular intent is supported or not supported. Let me go to the next part. Here I am showing exactly how, considering all the challenges, how we have designed our system. So just to give an overview, as you know that we have already discussed about the hybrid paradigm of on-device and cloud-based solution. So the first part of the slide shows you the overall picture, how it works. So when an user utterance comes, it passes through ASR. After through ASR, when we get a text, then comes NLU. So in the NLU, we understand whether an utterance or a particular kind of utterance can be supported in on-device NLU system or it cannot be. If it can be supported, we go for a planner, executor, and response generation system, and the output finally goes to the user's devices. If it cannot support, then it goes to the cloud-based NLU, where we have higher computing resources and even having higher functionalities to adapt. So now the very interesting question comes, what is this support? How do I really know that on-device NLU can support or cannot support? It can come from various aspects. It depends on how you design the system. It also depends on how you design the policies. Some of the things which is not worthwhile supporting onto the on-device. For example, when I ask for what is the weather of today in New York, then in that case, to understand the weather, it anyway has to go to an weather service provider. It has to send a REST query, REST API, get the query, get the response of the weather and give it to the user. So executing this part onto the on device may not be a suitable option. So let us park it for cloud-based solutions only, because anyway it has to fetch the information from the cloud. This is just a hypothetical example. I am not explaining exactly what goes into the product because I cannot open up the entire product design, Bixby's design in an open forum because of the business intricacies. Coming back to the one NLU system, whether it's an on-device or a cloud, how exactly a system in detail. Now let us go deep dive into the NLU block, which is there in top of the picture. In the second part of the picture, here we explain how the overall design philosophy of an NLU system. We first have a quick match scenario. What is a quick match scenario? Given an utterance where we can have a very deterministic match which can support a certain number of fixed variations where we cannot allow to fail, which are business critical. If those quick matches also we cannot find that there are quick matches are not matching, then we go to two parallel system. One is a rule-based system for a deterministic behavior. Another we go for a statistical NLU where we go for a more generalized behavior. Both of the modules uses one of the important aspect which we have emphasized in our previous discussions, that is user's personal language model. What is this user's personal language model? This is a language model generated from the user's content. So your user's phone will be having his own personal content, his music, his contacts, and so on. So to make the classifier robust, the rule-based or the statistical can avail the personal language model and infer. So one of the important feature, if any token or a phrase is matched against the personal language model, it gives a very strong feature for a classifier. It helps the rule-based NLU or a statistical NLU to perform better. When the rule-based NLU system and the statistical NLU system gives the result, we have a separate module which picks out which one is the best to pick, whether it's a rule-based system or a statistical system. Once that is done, it goes for a response generation part. The response generation is a very well-defined protocol and has a lot of design challenges. The response generation has to be unique and should be adapted so that when the response comes from this smart assistant system, the other clients, whoever is sitting onto the device, whether it is a refrigerator or a smartphone, should be able to understand at its ease. Then response generation happens, and finally again, when it response goes, the actual command gets executed and user sees the picture, or user enjoys the output of the voice assistant system. So this is the overview, the design paradigm of a unimodal NLU system. From here, let us jump to a multimodal NLU system. Why I call multimodal but multimodal NLU, I will explain it. Before jumping, when we go for a multimodal system, what are the different challenges comes with respect to the unimodal system? First and foremost, the challenges is very easy to understand. The input space enlarges to a large extent. So instead of not only voice, it becomes a conglomeration of voice, vision, touch, sensors, and so on. So when I say multiple input space, definitely a second problem comes in synchronization, because it will come from a different modalities. They may not be synced. For example, just for a hypothetical situation, if I raise my hand and say, come here to a robo, and I expect the robo to come to me or come to the point where my finger is pointing. So the vision input and the voice input may not be exactly time synchronized. So the synchronization is a very challenging problem. Then comes the conflicting modality. Conflicting modality means I have multiple modalities. In one modality, the intention is different, and another modality, the intention is completely different. Then the system can become confused. So to handle this conflicting modality, we need to identify the primary modality. Why I told the multimodal NLU is, in majority of the cases, we consider NLU or the voice or the text input as a primary modality. Now, when we see a multimodal system, so definitely, and it is very obvious that compared to a unimodal system, the input space has enfolded. So the context is also very, very, very wide. So the large context space compared to the unimodal system. In a unimodal system, the last command or the part of the sentences or the previous set of conversations can be assumed to be a context space. Whereas here, when I see for a multimodal space, all the existence of all the ambience of all the modalities contributes to the wide context space. Now comes when I say the large input space, so definitely there will be large number of outputs. Think of a robo. Robo can wave a hand. It can roll his wheels to go somewhere. It can blink. It can throw lights. It can speak out. It can have a display where it can tell the text. So the response also can come out in a multiple modalities. So input is multimodal. Even the output also can be multimodal. So this is another important area or the challenges to design and human computer interaction for a multimodal space, that is diverse response space. Now, this is a comparative analysis of what is the difference between a unimodal system to a multimodal system. As you have already seen, in a unimodal system, user speech goes via ASR, then NLU. NLU is assisted with an executor to give a final response, and there is a final TTS, text to speech comes out to the user. User hears that your alarm is set or message is sent to your mom, something like that. Whereas a multimodal system had a complete different way and the perspective. So it is not so defined that the output will be TTS. Here input also, we have an ASR, we have a vision, we can have a touch, so on. So instead of having only NLU, here we have a multimodal cognitive unit, which is basically a combination of multiple understanding unit where definitely, as I said, NLU can be one of the primary modality. Similar to the executor, instead of multiple cognitive understanding unit, we have a, multimodal cognitive understanding, we have a multimodal cognitive execution system. And the output is not exactly text to speech, the output is an expression. Coming back to this comparison, when I see this comparison, now how do we design, how do we progress? In one day, we cannot jump into all the modalities together. This is what is our vision. We have started with voice. We are working on voice and touch and slowly progressing towards voice, touch, and vision. So all these facets, so from voice to voice plus touch plus voice plus touch plus vision, or in future, voice plus touch plus vision plus sensors, what all things we can achieve? Let us jump into that. So these are some of the applicative products where the multimodal system can be applied. For example, a voice and a touch together, even in a smartphone-based system, can give a new dimension for user interaction. Another very obvious and important scenario is augmented reality and virtual reality based system. And definitely our one day, the friendly robots which interact with human should leverage, already they're leveraging the multimodal space. So the multimodal unit and the multimodal understanding as well as multimodal response generation. So these are some of the applicative products where exactly this multimodal can be applied. So this is where we have completed my talks, the journey from unimodal to multimodal. Now, as a team, I have already highlighted that to achieve, to cater to our user, to give a better user experience to our user, we are day to day conducting various facets of researches so that these technologies can be improved. I will just throw a glimpse of the researches what we are doing from our team, Samsung R&D Bangalore. So our major research area is scattered across these areas: advanced text analysis, multimodal analysis, text analysis for dialogue management, data analysis, and other language techniques. If I go deep, so our objective, so in this area of research we have identified with an objective, the first and foremost is creating a better user experience for our user, optimization of cost and resources, improving the accuracy. So optimization of cost and improving the accuracy goes into the next point, that is joint learning. It helps in that. Low corpus learning, that is for cost and space and resources. And for business expansion, multilingual and multimodal learning. So we have participated in different forums. Some of the forums names have been listed here. There are many other forums which I could not, due to the lack of space, I could not incorporate here. So there are two buckets here. Left hand side, you will see the direct research forums. These are our conferences where we have published our research papers. So Interspeech, ICASP, LREC, and so on. Even ICON, from the past 2 years, we are actively participating in ICON. And we have also, our team has participated in various AI challenges: Microsoft India AI Challenge, NASCOM AI for Good, Semiworld Task, and we are continuing our journey in that. So this is our overall research portfolio. This is almost the end of my talk, and I will just run you through the glimpse of the papers, where all it published and what are their titles, so that if you want to refer for your future or your own research, so that you can do it. So these are kind of researches what we have achieved. These are our papers. The details of the papers are given in the appendix. So in the text and dialogue management system, we are able to do various kind of joint modeling, particularly for intent and slot, end-to-end multi-stream vector representations for the method of dialogue, natural dialogue. We have also used low corpus learning. Here we have applied sentence similarity technique for short and variable length texts, which is required for some of the dialogue managements. For an advanced text classification system, we have also worked on sentiment analysis and offensiveness detection. We have also worked on introspective convolution attention network for semantic text classification, where we are significantly reducing the number of parameters of the attention network using a different techniques. Text classification for code mixed text, and also we have worked on novel code mixed embedding. We have also worked on multimodal analysis, where multimodal emotion recognition from speech recognition as well as text together. Speech emotion recognition with an auxiliary learning for gender determination, so that we can give a better user experience when we understand gender. Domain knowledge embedding based multimodal user intent classification. This is again with respect to our work with the text as well as camera input. This is one of the research papers have recently got published. Other learning techniques, for example, zero shot learning or phoneme based classification, also we have experimented for a different aspects. So this is the end of my talk. I'll just run through the appendix. These are our papers if you want to refer in future for your research purpose. These are some of our research papers. So I have captured only the researches which we have done from 2019 and 2020. The prior research, the previous researches I have not incorporated here. You can anyway search in the open search engines like Google's and so on. That's it. Thank you very much. If you have any questions, I am ready to take it. Hi, Ranjan. I think I am in time.
Hello, sir. There is a question in the chat box from Kaveri and Ranjan. Hello, sir.
Yeah,
Yeah.
hi. Yeah,
Yes,
hi. I'm looking
there
at
is a
you.
question in the chat box from
Yeah. Do
Kaveri
you have a
and
space
Ranjan.
constraint on the language for it to fit into a mobile, etc.? If yes, how do you enforce them? Okay. So particularly for language model, the question. It's a very interesting question. So what we do typically, there are different aspects. Okay. When I say on-device learning, it is not only, even though I have talked about voice assistant, your particular question boils down to even keyboards, because keyboards also have language models. They widely use language models more than a voice assistant actually. So at a time, what we do is when the phone has a settings. So in the settings, when the particular language is enabled, that particular language model is enabled. For example, when the phone is set for a Korean, or the not only the phone, even the devices settings. When the devices settings, the application setting. For example, if I enable the keyboard in Hindi, then the Hindi language model only loaded into the memory. All other language models won't be loaded to save the space. That is the primary thing. And also there are many other approaches we continue doing it. That is the restricting the number of vocabs. There is a big challenge if you increase the vocab for various systems. I am talking in general, not only a voice assistant system. It also applied to a language model for an ASR. It also applied to a language model in keyboard, and also applied to a voice assistant different components. What we do is we reduce the number of vocabs, and as well as when the model is, so first is one language is loaded. Second is when after loading the model, what we put into the on device, we go for a lot of pruning techniques. We do a lot of quantization, lot of pruning, and also we ensure that the quality is met. We do not compromise with the accuracy, but we try to reduce their footprints in that way. I hope I answered the question. Okay, next question is considering a major challenge, especially when it comes to an edge implementation, is there any specific thing you do from this perspective? If you are considering about the edge computing related environments, this is whatever I have talked is primarily on device. I haven't talked about the edge computing related environments yet. We are working on it, but I won't be able to explain here what particular aspects of the edge computing we are handling in this space. One more question is, I can see that Radhika, there is a question, how have you handled sarcasm or indirect speech acts or indirect way of conveying intentions? Oh, very nice questions. Very nice questions. So first of all, when we go for a voice assistant, these are command driven systems. So here we are not very much worried about the sarcasm detection, but we do have a module called the chat. So when I enable clock, I enable Q&A, I enable many things. We also have a chat. So chat has a way of handling sarcasm. So there is a different, the module only, the chat module handles some kind of sarcasm. So sarcasm, in a way, we have also classified them and we create a response accordingly. So some responses are to give a better user experience with the sarcasm output also. But when it comes to the command driven system, we do not exactly handle sarcasm in a particular way. So there is no deep particular sarcasm handling for intent determination or domain detection for a command driven system, just to be very frank. Second question I see, another question is, what are the intents and slot recognition method do you follow? Okay, so as I showed at a very high level picture, let me go to this, sorry, let me go to the slide. uh, so here is the picture. Yes, so here if you see, we have both the, in the below you can see there is a rule based system also and there is a statistical based systems also. The rule based systems actually gives a deterministic behavior. So there are various kinds of rules, and the statistical has a different types of classifier, normal statistical classifier as well as a conglomeration of deep learning based classifiers. So the technology is very, very detailed and complex. So it has a rule based system, it has a typical statistical based classifier, for example a random forest, and also we use deep learning based classifiers. Due to the business constraints, I am not opening the exact core technology in this talk, but these are the three systems which are available. I think I have tried to answer all the questions. If there are any specific questions, I can handle. Otherwise, I'm handling over to Ranjan. I hope, Ranjan, I have done within the time.
Yeah, thank you, Siddharth, for a very wonderful talk on multimodal NLP system. And I believe the content will definitely help all the audience in designing their own multimodal NLP system. So I believe we are almost 10 minutes ahead of schedule. So if there are any other questions, please put it through, or else we'll take a break of around 9 minutes and come back uh, at 11 to visit the first paper uh, about neighbor contextual information learners for joint intent and slot prediction. So it will be presented by Bharatram Natarajan. Okay.
Okay, I think the authors can be ready for the next phase. Thank you, Ranjan.
Thank you, Sid. Hi everyone, and welcome back to the uh, workshop schedule. So for each of the paper presentation, we'll be getting around 15 minutes of time for covering the talk and additional 5 minutes to have a question answer session. Okay, and post that we'll move to another paper. Okay, so Bharatram, if you can, could you please share your screen? Hello, Bharatram, are you there? So Bharatram, please share your screen with the PPT.
Hello?
Yeah, we can hear you, Bharatram. So can you please proceed with your presentation?
Okay. Hi all. Sorry for the delay. I was not able to hear previously. There might be some mic issue or something. So Ranjan, can you please give me permission to share the screen?
Yeah, you can go ahead.
Yes, I think. Hope everyone is able to view the screen. So
Yeah, we are able to see.
yeah, hi all. Very good morning to one and all present over here. I really thank the ICON committee members for providing an opportunity to present my paper in this place. The paper named Neighbor Contextual Information Learners for Joint Intent and Slot Prediction. So the major objective of this paper is to understand the intent and slot. So let me tell you the history behind why this paper has been chosen. So currently the paper, so a lot of research, extensive research has happened in the area of combined intent and slot prediction, from individual models to unified model to happening with crazy accuracies achieved in 80 cents. Then why this paper are we trying to present? The reason is all the approaches or all the solutions provided includes at least one sequential module present. Now, the presence of the sequential module in the case of on device might be a tricky scenario because it introduces some latency. So to reduce the latency, is there any ways we can knock off entirely the sequential model and try with only non-sequential models using, say, CNN and attentions? So with the breakthrough of the BERT transformer, we are able to see that they have achieved the state of the art in a lot of areas in natural language processing without using a single sequential network. So that was a good start point for us, where we decided that why don't we use um, non-sequential model to try Edison SNPs as well. So we try to approach, instead of using a heavy duty BERT model or compressed BERT model, why don't we bring up something, a combination like a CNN with attention, or say only CNNs with shared networks. So that where we started exploring, and that's why we wanted to present this paper majorly is, here we wanted to provide a non-sequential solution to the current problem of Edison SNPs, basically joint intent prediction as well as slot prediction. So this is the major problem statement. So let me explain about the datasets just to be a recap for everyone. I think most of the people might be knowing of this dataset, but let me still rephrase on that. So we have opened on the two open source datasets called Edison SNPs. ATIS is nothing but airline travel information system. So it has somewhere it has intent and slot defined in it. Now the problem with the data in this criticality is it is handling mostly about any queries regarding the travels or regarding the airline availability, or can I book a taxi from airport to some hotel which he has already booked. So these kind of scenarios it's handling. Now the problem with the training data that is present in the ATIS is it's a skewed intent distribution, meaning there are some intent called ATIS flight, which has somewhere around, which contributes to more close to 80 to 90% of the training data itself, and there are other intents which are contributing to remaining 20% or even 10% of the same. So now the problem is the system able to, whatever the developed system is able to handle the skewness in the data and is able to distribute the system as well. So that's what the challenge in the it is. Now it's when we are coming to the SNP's personal voice assistant that has uniform intent distribution, but the kind of slot it's dealing with and the kind of training data it is dealing with, it makes it extremely difficult for a system to differentiate between the slots because of genericness in the utterances. So that is one of the biggest challenge for the SNPs to be handled, which is very, very difficult to be achieving even state-of-the-art accuracy, except for the BERT model. No other model has even achieved state-of-the-art accuracy in SNPs. Other models are extremely performing badly. So with this constraint into consideration, I'm going to the next slide. Now, what we approach the problem is, we are considering the problem of the intent prediction as a classification problem and slot prediction as a sequence modeling problem. And so if people are asking what is the classification problem is, given one output, I want to predict which class that the utterance belongs to. Sequence labeling problem is nothing but, given a sequence of words, what label would be associated to each word given the previous words were this. That's what the sequence labeling problem is. And the next proposal we are going for is the unified architecture. Now, what do you mean by the unified architecture means? It will be single architecture which does both the joint modeling of intent as well as slot prediction. So that is the next approach we are going to do. And next thing we want to do is we want to share the learnings of the intent and slot. That necessitates us to do a multitask programming where we are trying to achieve intent learning and slot learning separately rather than in a unified system which learns both. So next thing we are trying, as we said in the problem statement, is we are exploring the absence of sequential networks. So with this first level of approach we have seen as trellis network. Now the trellis network is a language model based network which has been achieved only using CNNs. But one thing they have done, the beauty of the system is the weights are shared in this system and the input is fed at each input layer, and the learning of the weights of each convolution is also shared across the layers. So the weights are shared both in the depth, temporal as well as spatial space. So that's where we started with exploring the trellis network. Now the problem with the trellis network is the problem I won't say, it's something like it's an input sequence, right? We are going and trying an output. So we felt like whatever the trellis network has been proposed, it's in unidirectional only, meaning it will go from T0 to Tm. Now there is an exploration of bidirectional trellis network. So how about handling that? So what we are proposing is we are proposing a novel bidirectional trellis network, which handles two parallel network encoders, one for forward pass and one for backward pass. And we reverse it and concatenate the output, and we predict the final predictions for intended slot. So that's what the trellis network we are exploring about. So here, how the trellis network works, basically. So the trellis network technically works something like, it takes the input utterance as an input, and it converts to some embedding information using some embedding weights, say glove embedding or something. Now, the beauty of the system is that weight is going to be same across all the layers, because the same input is going to be given layer wise. So when it is given a layer wise and we are trying to calculate the output, so that value is same. So the weight is going to be shared across the layers in the spatial nature. Now, next thing is the temporal nature. So now how to share the weights in temporal nature? So that's where this diagram is explaining now about. So now, basically what initially we do is, we compute the previous. So basically it happens with the activation of the I+1th layer based on the ith layer. So the input of the ith layer are these four. Basically we split the input into four chunks. After splitting them into the four chunks, we do a con 1D of the previous information as an input and get an intermediate transformation. After getting the intermediate transformation, we apply an activation function f. That activation function f will transform it to the final I+1 final representation. So here the output is nothing but the previous t-1th information is fed as an input to t, like that it goes on. So this is how we are actually calculating the trellis network for a I+1th layer works. So this is the working of the trellis network, and basically what we have done is we have utilized the functionality of trellis, and we are going to expand it further by saying, how about we produce a parallel bidirectional trellis. So what we did was, whatever the embedding we calculated as an input, so the input utterance, we reversed the input utterance and gave it as to another parallel trellis network. So the input utterance is being shared both in this level, so batch size, sequence length, and embedding size. So this is going as an input. After doing the trellis encoder information, what we have done is, this person, basically it has the forward trellis network encoder gives you an output with respect to forward utterance. The backward gives me with respect to backward utterance. Now fusion layer fuses both the information, and then now the fused information, we are just trying to predict an intent and slot. For intent, we flatten it and do a linear transformation, predict an intent using softmax. Here for the slot, we just do a linear transformation with softmax as a output, and we do a slot prediction. Now, what is the kind of fusion that is being happening here is mask, flip, and concatenate and linear fusion. Now, so why we have chosen these fusion layers are, the fusion techniques might be able to predict, give more insights on how to fuse the informations and go about. So that's why these two fusion techniques are chosen for consideration. The next kind of architecture that we are exploring about is something called as a N-sigma architecture. That is nothing but neighbor contextual this thing. Sorry, this one is not performing well. Yes, so I'm so sorry, guys. So the next architecture is contextual information projector using multi-head attention module. So what is meant by the neighbor contextual information projector? Now, when I'm using convolutional neural networks, I can use a size of, say, window size of, say, 2 and a 1 and a 3. when I'm using different window sizes. So I'm capturing an n-gram feature information from a given address. Now, I wanted to see the importance of the n-gram on the unigram. Now, the reason why you want, because in the case of SNPs dataset, there are a lot of slots where the training data doesn't have words as a part of the slot, but expects in the test data to have it. Example, so any phrase containing the, my, a, they are present in the training data as normal words, not in the slot inside. So for capturing those scenarios, we felt like when we feed this kind of information, there's a high probability multi-here attention won't give attention to that the positional word information because it has not seen that. So what we thought was, we thought like if I capture the neighboring context, neighboring words as a unigram, bigram, trigram, using that information, if I calculate the importance of the same, there's a possibility that when I capture the Michael Jackson or something like that. So when I'm catching the Michael Jackson, I know that it might be a part of the slot. So that might contribute majorly to the unigram learning. And that unigram learning is what I need to give importance about. So when I know that a word might be useless in a unigram and a bigram, but it's important in a trigram. So for the combined word D, I need to give its importance higher weightage. So for that, we are doing addition layer in this place. So that's why we are first doing a multi-here attention followed by an addition to get a neighbor context to information projection. So what now it has is every word's importance based on the unigram importance, based on the bigram importance, based on trigram importance, all added, and then we are having the final representation. After that, we are doing a multi-here attention on top of it, and then we are predicting with CRF and without CRF layers. And without CRF at that time, what we do is we just give it to a normal slot prediction with linear transformation. With CRF layer, what we are doing here is we are passing through the CRF layer, and output of it, we give just a softmax prediction out of that. So we are able to see that the CRF layers are able to, basically this neighbor contextual information with CRF is able to perform the state-of-the-art accuracies on various architectures used for AGs and SNPs. The improvements are shown in the diagram. So we are also able to observe two things, that with CRF, we are able to observe a significant improvement in accuracy with the case of without CRF, basically. And mostly it is majorly seen with respect to the slots. If you see the slots, that's a huge difference seen, because the lack of sequential information is captured in the CRF and it's able to better enhance, because we are using a B2B algorithm to see that what is given the previous word, what is going to be the probability of this label for the next word. So that calculation is happening using the B2B accuracy. So, and what we have concluded from this here is, we are able to see that without a sequential model, we are able to achieve a layer of CNN with multi-here attention without any transfer learning weights from different architectures to here, and still we are able to beat state-of-the-art accuracy over here. And the next thing is, we are also able to see that the neighbor contextual information projection module is able to capture the importance of unigram, bigram, and trigram well, and also projects the importance of the word better, so that we are able to clearly visualize that. And next one is the trellis network. It's a very good trellis network is a very good option. Okay, I'm so sorry guys, some connection issue happened. I'm just reconnecting. I'm sorry about this. Another connection has come into the system, and I'm still relogging. Sorry for the interruption cost. So majorly what we wanted to say is Trellis network is another good network where it is pure CNN with weight sharing this thing. So weight sharing, this is actually a very good concept, but with a little bit more exploration or inceptions, we feel that it would be able to achieve the intended output, or even it would be able to beat state of the art with this. So that's about this paper, guys. So any questions you guys have? Can you please type it in the chat? For me, somehow the audio is not working fine. So it would be better if people types it.
So Bharatram, there is one question. Can you please have a look at the chat?
Did you try distillation for bird? Okay, let me go one by one. Why trellis network is chosen? So it's a very good question. Trellis network, why it was chosen was the CNN network with the shared weightage is something which is very intriguing. And even though it's a very high module, we are able to see that the shared network, first thing, it reduces the model complexity, it reduces the model network structure. And the second thing is sharing the weights across the different layers in the temporal and spatial direction, something new, which has not been tried by many people. So we felt like it is also one of the good area to approach, because we would like to explore the impact of the layers or the number of layers on the trellis network with the shared weights happening across the temporal and spatial direction as well. So that's the major motivation why we chosen the trellis network. And did you try out distillation of the BERT models? Hi, Kaveri. We have not tried for the same actually. As you said, yeah, BERT models have defeated state of the art to such a great extent. Actually, for SNPs, their SNPs slot prediction, their model has reached to such a great extent. I don't feel any model would be able to achieve that accuracy. So we just wanted, what our exploration was, is it possible to bring an equivalent BERT model, which is not high weight? We have to give this exploration. That's a major objective why we didn't touch this space. But yes, this is a good point which we will try in the future courses. Any other questions, guys?
Okay, if there are no more questions, we can proceed to the next topic. I believe it is
Okay.
a different paper from same BR, Bharatram. So the paper name is Unified Multi-Intent Order and Slot Prediction using Selective Learning Propagation. Okay, so we can proceed with that. So Bharatram, are you going to present it?
Hi all. For some reason, whoever is talking, I'm not able to hear. Let me try reconnecting to the Zoom meeting. Just wait for 2 minutes. I'm sorry about this. Hello. So are you able to hear me properly?
Yes, Bharat.
Yeah, now I'm able to hear Sid. Thank you. Thanks a lot. So shall I start with the second paper now?
Yeah, we are. Please go ahead.
Yeah, sure. Thanks a lot, guys. So I'm sorry, guys. Someone again disconnected my system. It has come now. Let me reconnect again. It was really disconnecting the system. Someone has restarted the system itself. Great. Hi all, very good morning to one and all again. Sorry for the late delay. So there was a small confusion which has been resolved now. So let me, thanks for providing an opportunity to provide this new area of multi-intent. So let me go about presenting this paper. So this paper is about unified multi-intent order and slot prediction using selective learning propagation. Now, the major objective of this paper here is why multi-intent. Now let me come to that things first. First thing. Now the thing is with the advent of AI assistants, so like Samsung Bixby, Google Voice Assistant, Amazon Alexa, Cortana, Microsoft's Cortana, everyone is able to achieve on the single intent and slots with a very great accuracy. Everyone has been able to achieve the reliability, so everything is achieved. Basically, the robustness, exploration into a lot of devices and things. Now, this necessitated when the robustness are being things, the scalability are being looked into the consideration. This might need a scenario where user might be saying different utterances to be executed in different devices, utterances to be executed within the same device, but from different domains, also to be handled by the system. Basically, to make the conversations to be make it more conversational and also to make it more robust in such a way that the system is able to handle any number of intents stored by the system, and that way also it gives a very good reply, very good user experience. So that's the main motivation behind this multi-intent. So to handle that one is, if I give an utterance, basically, for an example, in camera, there are a lot of settings we can use to take a picture, basically. So one utterance is something like this: capture a wide selfie shot after changing the front picture size to 12 million. So 12 million is nothing but the settings of the front picture size. In the settings, there is one front picture size settings which can be set to 12 million. And also the wide selfie shot is one mode of the camera to take a picture. So taking these things, so basically the camera has to execute two intents here. One is change the mode, change the settings, and then take the picture. So currently there might be intents where handling while selfie shot alone is there, handling the settings alone is there. Now if user gives like this, the developer should not be forced to write one combination rule, writing all the corresponding dialogue managements, handling all the things, which is going to be a redundant task for them because they have captured individually. Why can't the system be generic enough to handle this in the future cases? So that's a major objective why this exploration is chosen. So first thing what we have to understand here is, now what are all the intents present in the utterance? That has to be understood with system. And if I find the intent, now the intent segmentation. Now, why intent segmentation is needed is an intent of the system is present in part of the phrase and not the entire utterance. So if I find that phrase, it would be beneficial for me to execute things based on that particular intent only. Why means for a particular intent, it might have associated slots. And if I want to execute with intent with associated slots, if I find a phrase or segments of containing that intent, it would be better. So that's why we are having intent segmentation prediction as well. So that is nothing but the order of execution we call it. Okay, so that is nothing but the intent segmentation. The next thing that comes into the picture is order of execution. Now, order of execution is needed. Why? In this utterance, if you see, I should not change the mode to wide selfish shot, take a picture. Before that, before taking the picture, I need to set the picture size, the front picture size to 12 mil. After that, change to wide selfish shot and take a picture. Because here the statement is saying like that. After denotes doing something after doing the other intent. So that's why we have to understand the order of execution. So that's why we have to do all the 4 informations and also associated slots for each intent. So that's why that's a 4-task system where it should do dynamic intent predictions, intent segmentations, associated slot finding, and order of execution. So if you see here, for a sample utterance of this one, capture a wide selfie shot after changing the front picture size to 12 mil, I have to find the intent segments as follows, like capture a wide selfie shot is one, changing the front picture size to 12 mil is another. And slots are nothing but the wide selfie happens to be a mode, French picture size is picture mode, this thing 12 mil is picture size. These are the sample slots for the given utterance. And the order is actually, I need to say, changing the front picture size, intent containing the changing the front picture size to 12 mil, that should be executed first, and capture a wide selfie shot should be executed second. So basically C3 should be executed, sorry, C23 should be executed first over C3. That's the main intention. What is the order of execution? So with this in mind, we are going to so here, how we are going to approach this problem, how we are going to do this problem. So what we are doing is intent prediction is considered as 2 levels. If we are doing word level intent prediction as well as sentence level intent prediction. Now, why a word level intent prediction is, it is aiding in intent segmentation. Why a sentence level intent prediction is, I would like to know how many intents are present in the utterance so that a system which is developed using single intents can handle multiple intent information execution easily. Then for the slot identification, I am considering that a sequence labeling problem. Similarly, the order identification is sequence labeling problem. So slot identification, we know. Why order identification sequence labeling problem is, for the found intent segment, what are the orders associated? What is the order I need to associate for that particular phrase or the segment itself, entire segment itself? So that's what the order identification is all about. So that's why we consider that as a sequence labeling problem. It's achieved in word level. So now for this, current, as to best of my knowledge, when explored, the research community is not having an open source data set which handles both the intent slot and the order of execution. So this is the one such data set that is being exposed to the research community, which contains few things. First thing is, it's a low corpus data, meaning it has only 1850 training set and 350 test set. Now the problem is, why do you need that low corpus data? Because it will overfit the model. Now the thing is, in the AI community sector, I should not go about creating all possible combinations of multi-intent data just like the way we do for a single intent. Because if I do that, then the model is not, basically I'm teaching the model to say, I will give you more data for you to generalize. So if I'm able to generalize with very less data, say very less 8% of multi-intent training data, only percent. In the training corpus, only 8% of multi-intent training instances are present. Would I be able to achieve or not? Or 5% or 10%, like that. So that's the major objective of this problem. And next thing is, since it's going to be multi-intent, the complexity of the utterances in the natural form when people are talking is going to be high. So for an example, if you see, flash is one intent, taking a picture is another intent. Now, basically take flash switching on is one intent and taking the picture is one intent. So here it's clearly visible that there is no breakdown between two intents. It's going to be very difficult for system to say just flash to be one intent and take a picture to be another intent. So that is where the complexity of the multi-intent utterance is coming into the picture. Next thing is, So to handle this complexity, we have divided the task into 4 different scenarios. So if you see here, independent intents within the domain. So we here this data contains about gallery and camera. Well, intents, some 8 intents and 3 intents. Gallery and camera has individual intents of its own. So we wanted to combine them independently and dependently. So there are some intents which are independent of each other for its execution. So independent intents can be exist within the domain as well as outside the domain. So that's what the combination types are talking about. So independent intents within domain is one sample utterance where share multiple pictures and add the latest picture to wallpaper, like that. So this kind of combinations can be told, so dictates what kind of natural utterances the user can say to execute certain things. So the 4 combinations are independent intents within domain, independent intents across domain, dependent intents within domain, and dependent intents across domain. These kind of combinations exist basically. So next thing is going to be the low corpus data. So if you see here, single intent training data is 92% present, multi-intent training data, training samples in the training corpus is only 8%. And then what we did is we reversed basically the test data corpus to have multi-intent training instances to be high, single intent training instances to be high, to be low. Because I know very well single intent is performing already well, a lot of models are performing. So here this major construct is, with this low corpus training data, am I able to achieve a very good multi-intent recognition as well as single intent recognition? And the major concentration multi-intent because it is having only 8% of the entire training corpus of 1896. So this is how the data set is prepared. And this data set, if you see here one sample example that is shown over here, is nothing but this one, shared by docs photo. But first, let's run camera. So this is one sample example of the training data. So now let us go to talk about how to address this problem. So here, the training data is the form as shown in this place. If you, I'm sorry, yes. So if you see here, the training data is returned in basically a regex kind of a pattern where whatever is present in the less than greater than symbol indicates the order phrase, and whatever is present in the parenthesis immediately after the less than greater than symbol is nothing but the order ID, or what order should I need to assign, the order label basically. So similarly for intent, we have written whatever the intent to be produced is inside the square brackets, and so that contains the intent phrase, and whatever is present inside the parenthesis immediately after the square brackets indicates the intent label. Similarly for the slots, we use curly braces for denoting the slots, and the immediate parenthesis denotes the slot label name. So this is how it is. Now the data preprocessor, what basically it does is it tries to get the tuples of order, intent, and slot extracted from the system. So for the tuples of order extraction, what we do is we follow the less than greater than symbols present in the utterance. Since there can be multiple less than greater than symbol is present, I can write a regex, find all such patterns, and for each order tuple, I will try to extract the corresponding intent phrase along with the intent IDs using the regex, presence of the square brackets, present and close of the brackets followed by a parenthesis. And also in found intents, extract the slots present by using the curly braces, using the curly brackets along with the followed by the parenthesis. So extracting that, after that I replace those patterns found with the actual slot phrase so that it will pure be a sentence in the order level. So it is being followed, it is being applied in each level. So first I replace the slot pattern with the slot phrase, and then intent pattern with the intent phrase, and then we will be having only utterances with order phrase, or utterances with order ID, utterances with intent phrase, intent ID, and slots with slot phrase with slot IDs. So this is how the data process extracting the utterances. So after extracting the required informations in the form, you present them in the IBO format of intent, order, and slot. Now, after pre-processing the data in this way, now what we do is we feed it to architecture. We explore several architectures. Here, there are 4 architectures we are going to talk about. The first architecture is going to be just a bidirectional GRU with to encoder presence. So now this architecture, what basically it does is, we pass the utterances through embedding layer, pass it through bidirectional GRU. Bidirectional GRU captures the contextual information importance of the word in the given utterance. After that, we add it with positional embedding and pass it through two encoders. Basically, these encoders are nothing but the transformer encoders, which enhance the relationship of the phrase or the word with respect to each other. Like for a word dependency is present in different phrases, how to capture that is what this encoder is all about. So similar to transformer encoder only. So we are using two such encoders, and output of the encoder we use it to predict directly a word level intent, word level order, slot sentence level, sentence level, word level slot. So when we explore this architecture, okay, before exploring this architecture, we have tried with several open source data sets, open source already existing state-of-the-art architectures, trying to expand it outside. We were able to see that the system is unable to achieve a very good accuracy. Even it was not even crossing 40% when I tried to just predict the multi-intent and associated slots present in that. So we are able to see that it is not able to achieve the state-of-the-art. So because we didn't consider them as a words segmentation classification and also a multi-intent classification, we did only a multi-intent and this thing, multi-intent and slot prediction. When we did a segment level slot prediction, even then the model accuracy was very bad. With this data, it was coming to only 60%. We didn't capture that. We wanted to capture the best accuracy comparisons. That's why we went with three different variants of the novel model and one best model amongst the existing state of the art. So this is the first exploration architecture. In this architecture, we are able to see that the system is able to handle simple slots prediction properly. Simple slots are slots which are like very distinct, which can be captured very easily. Complex slots are going to be the slots which are kind of open title, where differentiation between the continuation of the slot and start of the next intent is confusion point exists. So example, like show me the pictures of trip to Korea and US, and show me the pictures of trip to Korea and share it. Now, if you see here, trip to Korea and US is the actual slot in the first utterance, and trip to Korea is the actual slot in the second utterance. And if you see, and share it, sharing is going to be another intent, and showing is going to be one other intent. So here the model should be able to handle this kind of complexities. That is the boundary detection of the open slots. So this simple slot is able to handle properly where there is no confusion point between the continuation of the start of the next intent or the continuation of the slot. So, but simple relationship between the intents and slots where the boundaries are very clearly defined that there is no overlap between the intents exist. So it is able to handle that. But it is failing in handling the boundaries. Basically start of the next intent. So if you see here, there is one utterance in this graph, which graphically represented display camera app to make me a crazy emoji. So here the intent is clearly told that up till display camera app, it is able to capture properly. After that, make me a crazy emoji is captured as an intent very clearly by the system as different intent. But the order predicted by that particular model is surprisingly one. It's saying that there is only one intent existing. Now there is a mishap. Basically, I have given clear intent, but the order is different. So that clearly shows that when the utterances are told more naturally, or it's going to be the combinations are going to be very complex. Basically, after using something like that, the system is unable to handle it. To overcome that, we proposed a next level architecture. This next level architecture uses, first thing is multi-head GRU. Why multi-head GRU? When bidirectional GRU, in a particular importance of a word in the given utterance is captured, but that the hidden learning is majorly contributed by the current word and lesser information is captured from different words. To enhance that, what we thought was, why don't we enhance the learning by using the multi-head concept only? Instead of attention, let me put a GRU in that place. So we tried a GRU by first splitting the chunks into 4 different chunks or n different chunks. Split it, pass it through each network, learn the embeddings and concatenate them. Now, each network will learn the importance of the word with respect to different phrases. Each different phrase at different positions. So that aided in capturing if a word is present in is influenced by multiple phrases in multiple positions, it is able to capture better is the hypothesis behind this multi-head GRE. And that's how we did that. After that, we passed through the positional embedding and passing through two parallel networks now. Now, why two parallel networks is, I know very well that intent and slots are interrelated to each other. But if I divide the task between two networks, where I will have one learning related to intent and order, one learning related to slot, and I can influence the importance of slot to intent and vice versa, I would be able to better project the boundary detection as well as intent segmentation and slot segmentation, slot identification. So that's the major hypothesis behind it. So that's why we went through this architecture when we found that there's a significant improvement in accuracy. So first level we understood is, if you see the parallel network 2 is predicting intent word level, sentence level, and order word level. And if you see parallel network 1 is predicting slot level. So what is the outcome we have seen here is, it is able to differentiate between the slot boundary and start of next intent well. It is able to differentiate in some extent, and some it is not able to do. And slot level improvement accuracy has been observed, but still the order and intent detections are not in sync. Meaning, I am keeping the order and intent learning in the single network, and that is still creating some confusion point between them. So it has improved, but it's not good. So one occurrence we have seen is click photo and food mode after turning on flash. If you see here, I am clearly indicating that intent is click for food and photo and food mode. After that, it is clearly telling the slot. It is telling the next level intent is turning on flash. It is clearly segmented the intent. Now, when we went to the order, again the surprising part happened is why the confusion point existed. Like I have predicted click photo belonging to order 1, in food mode to be belonging to order 2, and then turning on flash I'm predicting as order 1. Now, why click photo went to order 1? It is able to influence us. We found out in several trials that still the intent and order are being learned that way. So instead of creating one parallel network to order prediction as well and make that learning and then make a huge fusion, we thought like, why don't we make a order importance learner module fuse with the intent prediction and predict the final word level order. So that's why the final architecture we are proposing here. So up till the importance parallel network 2, everything is exactly the same as the previous network. Now, importance learner module 1 and 2 does the learning of the intent and slot, intent and order by one and slot by another. So after that learning, what we do is we do a word level intent prediction here by the model 1, and model 2 we are doing a slot prediction. Now what we do after that is that word level intent. So the output of the encoder is going in two ways. One thing is which going to another order importance, where we try to understand the importance of the learned intents for the order, and we do a fully connected network to bring it to the order dimensions, and then we add with the intent predictions in the word level intent. After adding it with the word level intent, and then we are again going for order level prediction. Now, why are we doing that? The thing is, I know the intent segmentation is proper in most of the cases. When I know intent segmentation is proper, if I add with the prediction of intent segmentation, it will nullify the errors that the order level intent level segmentation is found here. It would be able to nullify the problem of click photo when it predicted as order 1 when it should not have. Because if I have predicted the intent for this click photo as differently, if I add it with this, then my hypothesis is the prediction would fall in this angle and it would make it better. And that's why we are adding it in this way. Using that, we have observed is slot boundary resolution is good, better inter order relationship has been achieved, but here also there are still confusion points which exist, which has to be improvised, but yes, it has been increased to a great extent. So this is the analysis. Yeah, one of the architecture we have found is the state-of-the-art, best state-of-the-art architecture which has performed well for this data is the attention, so basically encoder with custom decoder. So this paper, what the author is claiming is he is using a bi-LSTM as an encoder, and then he's calculating two kind of contextual information. One is the importance of the encoder, one is sentence level one is slot level importance prediction, and one is intent level importance prediction. So for the intent level importance prediction, he's taking the final output, final layers hidden encoder output, calculates the attention with respect to all the other intent information, uses that only. For slot, he's doing for every hidden encoder timestamp, calculating the attention. And in the output, what he's doing is he's using a single LSTM where the inputs are two things. For slot, it will be hidden contextual slot, hidden contextual information for slot, and the hidden encoder output at the current time t. For the intent, what he is doing is he is predicting contextual level importance for intent, and then he is predicting, he is taking the hidden encoder as an input along with that. Now, output will be of three types: word level intent prediction, sentence level intent prediction, and word level slot prediction. So this paper, he is also following the same approach as us. So basically, word level intent prediction, slot level, word level order prediction. So word level intent slot and sentence level intent. Now sentence level intent, why he has predicted is he wants to see what is the output for Edison snips. He has proven with Edison snips and shown that, and also with the internal data set prepared by him, and he has shown that this architecture is good, working well. And for single intent also, it's on par with the existing state of the art. That's why we chose this architecture. With that comparison, we are able to analyze that thing is, it is able to so here we have extended the output to predict order by where the output of slot is chosen for order prediction as well. So after doing that, we found that this architecture is good, but not as well as the model 3. Why? The first thing is we are able to see that slot boundary detection, beginning of the slot continuation and start of next intent is not properly gone, because in a multi-intent, the length of the sentence is going to be huge. When the length of the sentence is going to be huge, even though he is using a bi-LSTM in encoder, it might not be able to capture the long distance relationship. So that's why this is one limitation. And intent and order relationship, it's not predicted because I'm taking it from the slot output, one intent output as well. So this is the accuracy information we are able to see. The proposed architecture by the author, it has come in close, but not on par, basically. So here we are able to see a significant differences between model 3 and the proposed state-of-the-art architecture for multi-intent. So this is the analysis, and conclusion is that here the need for order, intent, and slot predictions has been generalized, has been quantized, and this need to handle the slot boundary and start of intent well should be handled. It's able to handle, and intent and order relation is able to handle well. There's a small improvement is needed in the edge cases that has to be handled. And selective propagation aids in better learning of module learning. So when I split it into intent and order in one and slot in one, it is able to handle it well within the model 3 architecture. The future scope for this problem statement is we are thinking that is we are planning to execute for anaphora resolution of slots within the intent. So, and across intent as well, we are going to think about that's the future scope of this paper. So hopefully, sorry. So any questions, guys? I would be able to answer that.
We have 7 more minutes to take some questions, and post that we'll move to the next topic.
Having few questions for this. Okay. Having combination of single intent and multi-intent. So I'm reading the questions for all. So it's from Siddhartha. So having combination of single intent and multi-intent in the same dataset, do you see a model bias for one of the category? And the other question is, if an intent is spread across different parts of the sentence, will this approach be sufficient? Please share your thought. So yes, having combination of single intent and model bias for one of the category. So here for the first question, the combination of single intent and multi-intent, to whatever data we have collected and worked upon, we are not able to see a bias that single intent is always being predicted more than a multi-intent or vice versa. We have seen that the single intent as well as multi-intent are predicted properly. At least it is able to differentiate between the two categories, whether the utterance is single-ended or multi-ended with very, very good accuracy. The segmentation is only one problem that it is lacking upon, because the thing is system has learned the single intent models well, so it is able to differentiate between the single intent and multi-intent boundary detections well actually. So that one we are able to observe using this approach whatever we have proposed. And the second thing is, if an intent is spread across different part of the sentence, will this approach be sufficient? Yes, this is a very good question, Siddharth. Actually, this is one area which the system will surely lack in. So where a part of the intent is present inside a part of another intent is going to be something which we have not thought or addressed about. This is an area which we have to explore upon. So this exploration is also should be captured in the feature scope. Thanks for clarifying on that as well, which will be explored in the future courses. Anything else, guys?
So Bharatram, there is few more questions in the chat.
Yeah, surely, Ranjan. Please ask.
It's already posted in the chat. Could you please have a look?
Yes, Ranjan. I am able to see from Siddharth 2 questions. After that, I'm not able to see any other things, any other question anymore.
There are some other questions like, do you want to experiment with type of concatenation rather any fusion technique?
Okay, yeah, okay. Saw that question now. So, yeah, so type of concatenation. So basically, we found this fusion technique aided in selective propagation, and we have seen in the single intent cases itself. Okay, so let me talk with respect to single intent. With respect to single intent, we have observed that the fusion techniques, when it was a simple addition, multiplication, or concatenation, it was not able to project the output well when compared to complex fusion techniques like MLB technique or MTB technique like and all, or even selective learning propagation techniques. So considering those things that has been observed, we felt like the fusion technique would be a better approach even for the second experiment. So that's why we didn't think of other fusion techniques to go about, because in single intent itself it didn't prove well. So we felt like exploring in multi-intent didn't go well. And also the proposed architectures of the unified parallel intent slot prediction using unified joint intent and slot prediction model has also been tried, and we found that it was failing miserably. Actually, it gave only 60% accuracy. Actually, that was one of my first papers, and it didn't give well. So that's why these fusion techniques were not chosen, and we felt like we will go with this selective learning propagation. Actually, do you think? Yeah. Additionally, do you think instead of concatenation, if I use addition? No, sir. Actually, this also has been experimented for addition, concatenation, multiplication. All the things during best accuracy came with addition actually, and the accuracy stood at 60% for this data. Because it's a huge difference, I didn't go about posting all the accuracy informations in this paper. We chose the best state of the art from this. So the unified unified parallel intent and slot prediction paper was having a lot of fusion techniques, which has not proven to be on par with this data set because of the way it was projecting the output. So that's why we dropped that altogether. And also the learnings of the system is not that good when compared to the proposed models. The learning of the multi-head attentions are far better than the learnings of the simple fusion techniques is what has been observed when we tried it.
Okay, so thank you, Bharatram. I believe we can move to the next topic. Thank you very much for your presentation on both the papers.
Yes, thanks a lot, guys. Thank you for providing the opportunity for me. Thank you. Over to you, Ranjan.
Okay, thanks, BR. So let's move to the next topic. The title of the paper is a lightweight sequence labeling model for emphasis selection of short texts. I believe Vaibhav will present the paper. So could you please share the screen and continue?
Yeah. Yeah. Hi, Ranjan. I am audible.
Yeah, you're audible.
Yeah, sure. I share the screen.
Sure, thank you.
I hope it's visible, right? Can you just
Yeah,
confirm? Oh,
the slides are visible.
the PPT is visible, right? Sure. Sure, I'll begin. Good afternoon, everyone. So I'm Vibhav Agarwal from On-Device AI team, Samsung Bangalore. Firstly, I would like to thank ICON team and workshop committee members for selecting our work and providing the opportunity to present our paper. So I'll be presenting our work on a lightweight sequence labeling model for emphasis selection of short text, which we have also termed in short as EMPLIGHT. So we can see in this slide itself that the words in the title have been differentiated by two colors, dark and light blue, where the dark colored words indicate that there are more prominent words in this text sequence, that those are the more prominent words, and others are not that prominent, which is the output of our own proposed implied model. So let's understand in the coming slides how this is working and why emphasis selection is an emerging research problem in natural language understanding domain. So we can see in this slide two different text layouts emphasizing different parts of the sentence, where the left one doesn't convey the intent at the first look, where the right one is more impactful. So emphasizing words and textual content basically aims at conveying the desired intention by changing the size, color, typeface, and other typographical features. This basically helps in conveying clear message by drawing attention to specific information. And this has become more critical now with the explosion of social media and messaging platforms. There do exist design applications such as Adobe Spark, MS PowerPoint, that perform text layout on image templates, but they only consider visual attributes of text like word length or the frequency of occurrence, but not the semantics of text or the user's intent. And if we talk about the text modality, there are tools like Monkey Learn tools by Amazon and Microsoft, which are not suitable for short text. And the core operation procedure of these systems is to extract nouns and noun phrases. And when it comes to existing emphasis selection systems, these are mostly offline models having high memory footprints, and those are not suitable for the storage specifications of mobile devices. We'll see about this in more detail during the presentation. So the question comes, how can the emphasis selection help in enhancing the end user experience? Well, word emphasis can convey user's intent in a much better way when it comes to visual communication, when integrated with graphic design platforms like Canva. Automatic emphasis selection can also help in improving presentation applications like PowerPoint. It can aid voice assistants and digital avatars to stress on words, pitch for different voice modulation for more expressive text-to-speech systems. Another application could be effectively summarizing the long pieces of text to effectively convey the information. So through this paper, we would like to propose EMPLIGHT, which outperforms the existing keyword extraction systems by using emphasis selection on short text, which automatically recommends which part to emphasize in the text, and which differs from existing emphasis selection architectures by ensuring a very lightweight model for efficient on-device inferencing on mobile devices. So moving on to the model pipeline. So for training the model, we used the officially released public dataset by International Workshop on Semantic Evaluation, which is the combination of Adobe Spark and Wisdom Code's dataset. So the data set consists of around 3134 sentences labeled for word level emphasis by multiple annotators. As we can see, this is a sample of the data set for few words. If we consider the word snow, so all the words are being annotated by A1 to A9 annotators, basically 9 annotators with the labels B, I, and O, representing beginning, inside, and outside. Where beginning and inside means the word is emphasis as per that annotator. And so B and I are considered for emphasis words, where O represents outside, meaning the word is not emphasized as per that annotator. So here we get the cumulative frequency of B, I, and O. So in this case, we have for snow, there's 1 for B, 2 for I, and 6 for O. Using this, we calculate the final emphasis probability, which would be B plus I, that is in this case, total 3 divided by 9, which is the total number of annotators. And using this emphasis probability, we need data labels for our model training pipeline, right? So we generate data labels using the emphasis probabilities by assigning 0 to low emphasis words, means having probability less than the threshold probability, and 1 to high emphasis words with probability more than threshold probability. We experimented with different values of threshold, and we observed that 0.4 yielded the best results for our task. So now we do have the data set ready. But how will we evaluate our model? So for this, we use MATCHM as evaluation metric. So let me explain in brief what it is. So we use MATCHM for basically M1, 2, 3, 4. So representing, if we are considering top 1, top 2, top 3, or top 4 words out of the text sequence for evaluation. So we use MATCHM as evaluation metric, where SM is a set of top M high emphasis frequency words in an input sequence of data set D. And SCAP M is a set of top M high emphasis frequency words based on model's prediction, means what model is giving, in our case, implied. And the intersection of these two sets gives the number of elements. Basically, we can say that how many elements which is given by our model is same as the ground truth. Finally, we compute the average score as aggregated measure that averages all possible MATCHM scores. So we can say, so the intuition is that MATCHM lies between 0 and 1, and higher the score means our results are more in line or more similar to the ground truth. So now talking about the architecture. So we approached this problem as sequence labeling task, and we began with a very basic model and enhanced that model incrementally with contextual information in the form of pre-trained embeddings and multiple input features. So to give an overview, we basically, what we do is we obtain first character level encodings and then concatenate with the word embeddings. The concatenated representation, we pass it to a bilistream layer and then again concatenated with the POS features. This is then followed by attention module and two fully connected layers. Let's discuss the key components of NPLIGHT in more detail. So as we can see in this focus region, we used a combination of word level and character level input representations. As in literature, word representation is known to be more quite suitable for relation classification tasks, whereas character level representation perform well on short and conversational text. So we used 2 layers of CNN with the 1D convolution layers with filter sizes 3 and 5 that helps us extracting multiple character level representations and handles misspelled words, as well as model subword structures like prefixes with prefixes and suffixes. We use the same number of filters for both the convolution layers, that is 16, which is selected based on the experimental results for optimal accuracy. Also, we use the subset of, in the final architecture, we use the subset of 50-dimensional glove word embeddings corresponding to our training vocabulary of 4.3K roughly, bringing the embedding size down from original glove size of around 160 MB to 2.5 MB. We did not and could not use embeddings like Elmo, which has roughly of size around more than 350 MB, or other BERT-based deep contextual embeddings having size more than a GB, as it's not feasible to port those heavy pre-trained models for on-device inferencing, which is the focus of our task. So now next, talking about the POS feature concatenation. So if we observe the POS distribution in the bar graph shown in this slide, so for our training data, we can infer that POS acts as very important input modeling feature, as we can see that the words with the POS tag with noun represented with tags NN, NNS, NNP, adjectives, or even verbs with VB, VBP, and VBG, they usually have very high emphasis probability, whereas pronouns and prepositions are less likely to be emphasized. Therefore, to incorporate this feature, we used a 16-dimensional embedding to encode POS tag information, which is then concatenated with the output of this bilistium layer. Yeah. So next, after this, we added attention module to give different importance to different words in input text sequence. So we use the global attention for that. After all, as we say, attention is all we need. So this is followed by 2 fully convolution layers with the sigmoid activation function. We are using the activation function as sigmoid because we want against every label, we want to output the emphasis probability with respect to that word. So now coming to experimental results. So we attempted numerous incremental changes to our model to enhance the performance. Also, all the hyperparameters we chose are experimentally decided to optimize the accuracy and ensuring that we maintain a small model size. As the proposed solution, which I mentioned before, is for mobile devices, our main performance indicators are model size and average match-M score. Here, this M1, 2, 3, 4 denotes how many top words we are considering if suppose the input sequence is of length n, and how many top words we are considering based on the probability for our evaluation. So there are a couple of things I would like to observations while experimenting. I would like to point out. So one thing is we observed that using the CNN gave us a better score as compared to LSTM because varying the size of kernels and concatenating their outputs allowed the model to detect patterns of multiple sizes. And another point is that setting the word embedding layer as trainable improved the overall matching score. This is because we are utilizing, we can say, language semantic knowledge acquired from the pre-trained embeddings and then fine-tuning it for our task. So basically concept of transfer learning. Hence, our final model has a size of 2.82 MB with a overall match-M score of 0.711. So as I mentioned before, in the data set was very small as we had only around 3K annotated samples in the training data, which makes it difficult to improve the accuracy beyond a point as we are using a neural model, which requires a lot of data. So to enlarge the amount of training data, we experimented with 4 data augmentation strategies, randomly removing less than or more than 1 word per sentence, uppercasing a word randomly, and reversing the sentence. So the intuition was that the model, we want the model to see more training sequences in different form. But as you can see, there was when we experiment, we have tabulated few experiments here, the best results, and we can see that there was only marginal improvement in the score, and the best score what we achieved increased from the earlier, what we saw was 0.711 to 0.716. But of course, there is no change in the model size as the architectures and the vocabulary remains the same. So let's when we compared our models with the, as we can see in the slide, the table, when we compared our MPLIT model with the state-of-the-art solutions, which are also trained on the same data set. These are the best models with the best scores. So we can see that though the models have these models have higher match-M scores with 0.747 for non-transformers approach and 0.804 for transformer-based system. These have literally huge sizes as they utilize pre-trained models like Almo, BERT, Robota, XLNet, making it unsuitable for the edge devices where resources are constrained. And the right side figure presents the emphasis heat map for some examples from the test set using our final model MPLIT. Here, the red colored boxes represent the words with the high emphasis probability from MPLIT. So for example, in this case, which is the title of our paper itself, the actual output of the model shows that words like MPLIT, lightweight, emphasis, and short text are the most emphasized words with the highest probability. So to conclude, so we proposed a lightweight neural model that can run on low resource devices and can greatly enhance the end user experience. Our best performing model achieves an overall matching score of 0.716 with a model size of 2.82 MB, which is as small as 0.6% of state-of-the-art systems. So there is continuous research happening in moving towards lightweight models, like thin versions of BERT have been coming out in the last couple of years. So we are also focused in this direction. But even if you can see, these BERT models are quite large in our context of low resource devices with our model size is even less than 3 MB. TinyBERT is one model which is very recently published in AI-NLP 2020 proceedings and looks quite promising. Our future work also includes increasing the vocabulary with commonly used words in English that also would help us to cater text of multiple domains. Thank you.
So thanks, Vibhav. Probably we can take some questions now. We have time for that.
Yeah, okay. Yeah, sure.
There are questions on the chat room.
Yeah, sure.
Yeah, so one of the question is how this task is different from entity recognition. Please share your thoughts.
Correct. So, and when it comes to entity recognition, that is also a sequence labeling task, but in that case, the criteria is identifying mostly the named entities in terms of location, in terms of organization, in terms of persons. So even though it's a sequence labeling task, but that's how mostly the named entity recognition works in that fashion. Whereas in our case, it's more about understanding the emphasis and which can be integrated to multiple solutions for improving the overall experience. Even it comes to conversational AI. So, I mean, that is even though it's both are the sequence labeling task, but named entities focus on identify key entities, name, person, location, organizations, or even information extractions like if there are time entities or dates entities, things like that.
Okay.
Yeah.
So there is one more
question. The question: have you thought of character embedding to reduce the dependency on embedding completely for other languages? Okay. So if you're asking to get away with word embeddings, is that the thing, or about language expansion? Just for clarification.
Yeah, first is the get away from word embedding, dependency on word embedding,
correct.
and second is what is your thought for language expansion?
Correct. I'll address both. Yeah, so actually, this is something very interesting. We also, while working on this, came across both these questions. So I'll address one by one. So when it comes to character embedding, so first we tried with only using character embeddings. That is one thing. So, and it did not give good results for this task. The reason being, so because it's English, if we, the reason being because the words, the language is such that the characters are such that the word level representations are important. But if you model it for languages like Korean, which are more agglutinative in nature, I have seen that in this sequence labeling task, only character embedding gives really good results. So for English, I have seen for a task like even named entity, because these tasks all our sequence labeling, so fall in the same domain. So for English word level, what I have experienced while working is required word level representations. But for languages like Korean, only character embedding is a very good idea, and it really works well. When it comes to language expansion, so currently we are only focused, the focus was only on English. Another way is very important, which while presenting you would have realized at some point of time, and that in this problem, for language expansion, getting the data is a tricky part. Because suppose because for any text sequence, if there is any word, whether to emphasize it or not, or I mean, for the training data, whether to consider that word as emphasized or not, that could be very much, I mean, people can have different perspective to that, right? It's very much relative. So how to get more data, more training data for different languages is a challenge. So if we can have it, of course, I don't think there is any problem for language expansion as well. But yes, we need to resort to methods like crowdsourcing, so that or different annotators annotating for different languages to accumulate the data, because as such, this kind of data is not very much, it's not really available in general. Yeah. Next thing, one was explain how we're able to achieve the small sound. Just using the word embedding dimension. Okay. Yeah. So, okay. So there are a couple of things, Sandeep. So as you are asking, how are we able to reduce the word embedding dimension? So one is key, instead of using the glove embeddings entirely, which normally does happen, because we have memory constraints, we only utilize a subset. So suppose our vocabulary was a 4.1 K size. So we only utilize the word representations corresponding to those words, so that it doesn't explode, because the parameters of our final model was around 2.38 lakhs. So the moment we increase the vocabulary or increase more embedding or heavy embeddings, that increases exponentially. So that is one thing. Of course, we experimented a lot. We just presented the best paper. We experimented with a lot of combinations of embeddings. Like we restricted the sequence length to 25. We set the word embeddings to character embeddings to 12. So all these, we wanted to kind of keep the embeddings in such a way that if after a point, if it saturates, there's no point of increasing it, so that the model sizes are in check. Also, this was the major idea to relying, as Siddhartha also mentioned, more on character embeddings and getting away word embeddings. So if you can do that, that would be really even more helpful for keeping the model size low. So correct.
So you mean to say how much was your vocabulary? You just took that portion from the embeddings, glove embeddings,
correct.
right?
Exactly. So another feature scope which could also, we have in, exactly. Sorry to interrupt.
No
another thing which we had in mind due to which we, as I said, fast text is another very good example which could be utilized due to the subword structure, right? You'll be knowing.
Yes.
If you are using glove, then it makes a lot of sense to try with that as well, and we might get, because of that, the way that is constructed, because that from there also that we can extract based on whatever vocabulary we have, the relevant embeddings, and can really utilize it, and that might give more improvement in accuracy.
Yeah, only one point, like when you say that you took a subset of the vocabulary from the glove embeddings, will it not cause a problem if the model sees the unseen word, like a new word which is not in your vocabulary?
Actually, good point. Which is very valid point. So as I was showing in the test set examples, just a minute. Yeah, in this. So in these, mostly at least 30 to 40% words are from OOV. So for OOV, we basically using UNK token. So basically, in a way, for modeling it a separate ID, which which we are assigning it to it. Another point is which really comes into picture is how the model performs on OOV, basically. So experimented, these are only few instances, and we have checked it is performing decently well. But of course, if suppose we throw the model and if we are inferencing all the words which are OOV, of course, it may not be that good as well in terms of performance. So that could be a matter of exploration and improvement. But as such, what we've observed is OOV words are handled reasonably well because, of course, we are utilizing character information, character level encodings.
Understood. Okay. Thank you.
Okay.
I guess there's no more question.
Yeah, there isn't any more question. So probably we can move to the other topic.
Thank you very much.
So the next topic is about named entity popularity determination using ensemble learning. I believe Shikra will present it. So could you please proceed?
Yes, sir.
Thank you.
I hope my screen is visible.
Yeah, it's visible.
Good afternoon, everyone. I'm B. Shritara Varna. I'm a co-author of the paper Named Entity Popularity Determination using Ensemble Learning. And I'm here to present about the work done by us. This is a collaborative research project between BMS College of Engineering and Samsung. So what is Named Entity Popularity Determination, or NEPD, and where is it useful? As we know that the process of identifying entities in a query string is termed as named entity recognition, or NER, and as the usage of virtual assistants and video music streaming services is increasing, it is necessary that the services provide the users with what they require and also give relevant recommendations. And for this, it is important to disambiguate between entities with similar names, and hence NEPD becomes important. NEPD is a process of using data other than the query string to disambiguate entities with same name. For example, if we consider the user says the phrase play wolves, then the virtual assistant has to disambiguate between whether to play the movie Wolves or the song Wolves. Again, in the music domain, it has two options, as there are two songs with the same name Wolves but with different artists. So the virtual assistant over here has to disambiguate between which is the best result provide. These are some of the related work that have been done in the field. The field of NER has been extensively researched upon, and several approaches have been established to get better results. But the field of named entity disambiguation and named entity popularity determination has been vastly unexplored, and only a few works have been done in it. Use of graphs and knowledge bases for popularity ranking is one of the approaches, while the use of personal history of a user to create a ranking of entity is another. BiLSTM, GCN, and RNN have all been experimented upon to improve NAD. Now I'm going to talk about the approach that was taken by us to solve this problem of named entity popularity determination. So first, this is a modular approach that was taken by us to solve the problem. And the domain that we worked upon was only music and movies as of now, and let's look at each of these steps in detail. So these are the features of the data set that we had. The data set was custom generated, and hence we had to decide upon the features that were to be considered by the model. The problem at hand was finding the popularity of a person in the particular domain and identification of the domain in which the person is more popular if there's a equivalent presence in both the domains. The idea behind the selection of these features is that the popularity in a domain is based on the worth of that person and the uploads received by that person for their particular work. So these are the different features named that were included, and these were the source from where the data was selected for each of these. Now, this is a data. This is a snapshot of the data file that we had, and also related to the features that we used. Now, as it's noticeable, there was sparseness in the data. This is because most of the entities weren't ambiguous. These entities were inclined to one of the domains and had no presence in the other. Some of the features that weren't populated because the data wasn't available for them. And these features were finally dropped. For example, if you see the screen time over here, there was no data available to them, but initially we considered it as a important feature, but we didn't have any data available to them, so we had to drop it. Also, a correlation matrix was built by us, and it led to dropping off of a few more features. The features that were dropped off were genre, region, and release date finally. So once we finally filled the data, so this was like a populated a bit more than what we had earlier. Now, this is the final correlation matrix that we had after dropping off of the features. And even after this, as you can see, because of this, because there was still sparseness that was still existed. And to deal with this sparseness, what we did was we filled up the data with some default values for each of these. Like for example, all the features that were related to the count of a movie's acted or the count of music awards and such, they were filled with the default value of 0. As if we took a median or a mean value for them, we thought it would corrupt the data set and the classification rules would become jumbled up. Now we used two algorithms for this classification. First, we encoded the data using label encoding. Label encoding was preferred over one-hot encoding, as one-hot encoding results in higher data duplication as it creates multiple columns. The first algorithm that we applied was decision trees. The intuition for chosen decision trees was it generates rules for classification, and the data that we had wasn't sequential for us to try out algorithms like RNN or LSTM. The tree that we used was built using the TART algorithm, and Gini impurity was a category that was used to split the nodes. We found that the data was being overfit, and hence we moved to random forest. Since random forest is an ensemble algorithm that is many trees are created on training data and prediction from each of them is taken, and the final output is based on the method of voting. Ensemble learning was preferred over here because the rules at times differ from one entity to another entity, and we thought random forest would be the best one, and it creates multiple trees, and each of these trees are different from one another based upon the rules that they were built upon. So these are the results that we found when we worked upon decision tree and random forest. As you can see, the decision tree gave us the least accuracy on the test data because decision trees are prone to overfitting on training data, and hence the accuracy on the test data is very less. Random forest, when we increase the percentage of the test and training data, when we varied the percentage of testing and training data, we found that the accuracy was increasing. And finally, we achieved the best accuracy when we had a random forest with test data as 40% and training data as 60% of the data set that we had. This is one of the sample trees that was generated by the random forest out of the 100 that we used for the N estimator. So over here, like as you can see, the first rule is based on the number of listeners that person has, and if it is less than 1.0, that is, if a person has no listeners, that means they belong to the movie domain. So it directly goes to the movie domains, and it I think checks if the number of movies acted is less than 12.5. So based on these set of rules, the algorithm was able to classify the entities and the data into their respective categories. Now, the problem of NAPD was to be solved without any contextual data or user history in the domains of music and movies. In virtual assistants, users usually they have only named entity without context or statement associated with it. It's just a verb like a play, and it's followed by the entity name. And we this is an ongoing project, and we are looking at increasing the data set and planning to extend this to other domains, including TV shows, podcasts, and radios, by selecting the relevant features and working upon them. This approach can be modeled to disambiguate between entities related to various domains without contextual information. Thank you.
Shrikara, there is a question in the chat. So can you please explain the data set one more time? So this is the question.
Okay. Yeah, so this was the data snapshot that we had. And like for example, this was a custom generated data set. So we didn't had any features or entities, so we had to mine them. So what we did was we first collected the features, like what features we thought were important in determining the popularity of a particular individual in those movies. And so first, like for movies, we thought these are the three major things, along with the number of awards that a person has got. So these will help in determining how popular a person is. If a person is more popular in the movies domain, obviously the count of these four uh, will have a higher value than the others for who is not so popular in that domain. So this is what we worked upon, with the intuition that popularity will be based on the works that they have done in that particular field.
Okay. So we can take some more question if there are. Okay. So I believe there are no more questions. And so thank you, Shrikara.
Thank you, sir.
Yeah. And so we are early ahead in the schedule. So what we'll do now is we'll take a lunch break and come back again at 2 p.m. So at 2 p.m. We will. So there is a panel discussion session moderated by Praveen. So the topic is about AI for real world and AI for future. Okay. So there are many experts who have decades of experience in SRIB, and let's hear from them about how the AI works for real world and what will be our future in AI. Okay, so with that, let's take a break and see you soon at 2 p.m. Thank you. everyone had a nice lunch. And so with that, we'll resume our workshop proceedings. And the next topic will be the panel discussion moderated by Praveen. And the topic is AI for real world and AI for future. So now I'll hand over to Praveen to execute the further proceedings. Yeah, over to you, Praveen.
Okay, thank you, Ranjan. Good afternoon, everyone. Welcome to the second session. This is the first agenda. The topic is AI for real world and AI for the future. We have here distinguished panelists in their own field who are their own thought leaders. Firstly, I would like to thank them for taking out their busy schedule and joining this session. So here we will be interacting with them on their own fields, how they are applying the AI and what is in store for future and what kind of challenges they are solving. And also in future AI products or AI development, what kind of changes are required, not just from the company perspective, overall government perspective, laws modification, or as a consortium, what changes has to be required. So with that, I will give a quick introduction for our panelist. Then we can have a discussion points one by one. So to start with, I would like to introduce Srinivas. You can wave your hand so that people can recognize you. Yeah, he is a principal engineer at Samsung R&D, where he leads ultrasound imaging unit. He previously worked in Philips. He has almost 15 granted patents and 15 international publications, and he's a senior member in IEEE. That's Srinivas for you.
Yeah, thank you.
Yeah. Next is Ratnakar. You can wave your hand, Ratnakar.
Hello, everyone.
Yeah. So Ratnakar is a senior director in Samsung Bangalore. He has 20 plus years of experience in wireless communication, starting from 2G until 5G. So for any Samsung phones, if you are able to successfully call, right, he's the prime guy who is enabling that. He's also a senior IEEE member and with 20 plus international patents. The next panelist is Srivatsa. He joined, or we have to. Srivatsa, did you join? Okay, so he will be joining soon. Srivatsa is a senior director with 20 years of experience in building software innovations for Galaxy mobiles. In his recent years, he's working on device AI platform and also is trying to solve AI problems on the device. He will be joining us soon. The next person I would like to introduce is Ritesh. Hi, Ritesh.
Good afternoon.
Good afternoon. Ritesh is a product leader, mentor, and coach. He has close to 18 years of experience in Silicon Valley. He worked on the domains such as IoT, mobile, and mobile identity before joining Samsung India. He led cross-functional teams in product management, business operations, UX design, customer success, and engineering at startup and large organizations across the US and India. Right now in Samsung, Ritesh leads product management for AI software features. So that's a quick introduction. Without much wait, let's go into discussion points. The first discussion point I would like to have is how is AI used in your respective fields? Define how it's changed end user experience, not on the technical perspective, but on the end user experience. So for this, we will go one by one. We will start with Srinivas, then
Okay.
we'll go with next person. Go ahead, Srinivas.
Thank you, Praveen. I think me being the first has some relevance, I guess, because health is wealth, or probably health has to have first precedence, probably. So with that take on that, how is AI being used in my field, that is healthcare? And in the entire discussion, when I'll be citing examples, I'll be referring to, when I say healthcare, it is primarily the radiology domain in the ultrasound imaging as such. So at this moment, the AI's proliferation as such in the healthcare is still in a very nascent stage. We are using AI in healthcare primarily for simplifying the workflow. If you have seen people who have experienced the way the number of forms one needs to fill up to get entry into the hospitals are quite cumbersome. If it is guaranteed by an insurance company, there are equally more number of papers to be filled up. So how else? First of even the entry of the patient, there can the AI simplify the data entry part of it. That's where the focus is. And also, if you look at in a trauma center, when a patient comes, he can't enter his let's say his age or the gender and things like that to even to make an entry there, because he's already in a trauma state. Can AI help in some other fashion of taking his biometric information and try to make a quick entry in, so that at least you can get his past history? So primarily, to cite first one is the simplified workflow is a major focus. That is the low hanging fruit, which you can term that one. And second thing is we want to try to get more enhanced performance, because there is a hunger for faster frame rate, because you want to see the beating heart. There is the bypass surgeries also now are going through like in heart surgeries where the live heart is not even stopped. So I need to get a frame rate which keeps a pace with the actual beating heart. So the enhanced performance is the second one. And the third one is most importantly is the improved diagnostic accuracy. So as you know, a typical radiologist is a pattern recognition guy. Because of years of experience, he's actually find a lot of patterns in the image data, maybe the chest X-ray or MR or CT or ultrasound imaging. So can this information can be coalesced by AI to say that, hey, have you missed that part of the nodule, which sounds to be very malignant one. So improved diagnostic accuracy is the area where the AI being targeted upon in the healthcare. And when you say end user experience, so for me, the end user is both the clinician, because that is a stage where we are in right now to evangelize the AI. So the end user point of view, the clinician, the current struggle or the one which we're trying to impress upon is that the clinician needs to appreciate that, yeah, the AI is really helping in his workflow. One of the use case which we at Samsung Bangalore have worked with a clinician based in Narayana Hospital. It is a biopsy surgery for a prostate cancer. So clinician, yeah, he is no god. He has still have two hands, of course. So he needs to hold a transducer in one hand and a biopsy needle in another one, and needs to look at the ultrasound machine to do that kind of procedure to find the right lesion there. It's quite a cumbersome procedure to see post-operative. He must have a clear picture of an MR, and he's doing a real-time surgery there. So can the AI help him by way of seamless merging of the image and try to facilitate those clicks and buttons? It is very intuitive and says that, hey, I got it, what you are looking at it is a right picture. Now you can take a biopsy shot at it. So we are helping the clinician by reducing the number of clicks on the knobology of the ultrasound. And second thing which we attempted at Bangalore was a labor and delivery. So the decision to say whether the delivery can be a cesarean or a normal delivery is quite error prone, and sometimes even can lead to some kind of a distrust between the patient and the clinician. So the way to judge is that is the fetus head is a right orientation to make a decision whether can I go for a cesarean or a normal delivery. The AI will really help it. We are not talking about any kind of a diagnosis here, but we're just helping the clinician to say that the orientation is perfect as per the defined norms. Now you take a call. Ultimately, we are not playing the god. It is a AI helping the clinician to make an informed decision, which anyhow is to do it, but we are reducing the number of clicks. On the patient side, quickly, on the OB side, where we worked around, if you see in the typical OB patient who comes, a woman for a trimester scans, the bladder needs to be full. It's quite traumatic if you have seen it in a typical OB scans which happen in hospital now, where the fetus head may not be in the right direction, but the patient is asked to wait for some more time to hold the bladder full. that's quite painful and it consumes time. But having an AI which we are applied there, one can just capture the volumetric data, and offline one can get the requisite image scans done, and it really makes the OB scans like a jiffy. Maybe in between 20 to 25 minutes, one can get all the scans done. The patient can go back to her normal routine or job. That's where the AI is working for us, Praveen. Thanks.
Okay, very interesting. I mean, you have two end consumers. One is the clinical, who can, you are aiding him in taking a right decisions, and the other person is the end user, meaning the patient itself.
Right.
It's very interesting. Thank you, Srinivas. Let's move to Ratnakar.
Yeah, thanks, Praveen. So, hope I'm audible well enough.
Yep.
Yeah, so I think most people will wonder, I mean, because in their minds, communication networks and AI are probably poles apart. So they could be wondering, I mean, what is the link between these two? So, well, I mean, for AI to work, right, all you need is, you need data in the first place, and then you identify patterns, and with that patterns, you make some decisions or, or suggestions, right?
Right.
So, well, communication networks handle data. I mean, all the world's data is flowing through the communication networks. We are sitting on this pile of data, right, to do something out of it. So in that sense, there is a huge potential, and certain low-hanging fruits have already been, fruitful. I mean, have been put to use. So best example, I mean, for us, the end users are all of us, right? Whoever is using a communication network, we all are working from home over past several months. We're all using several networks, your mobile, your Wi-Fi, you may be on a Airtel, Geo, all the different networks. What every consumer expects from a network is actually, almost near zero downtime. I don't want my tower to give up and when I have to make an important emergency call, right? I need my network to be in 99.999949 accuracy all the time.
Yeah.
And secondly, I don't want anybody to attack my network and, steal away my credentials or, do something that the network node goes down. No attacks on my network infra. So for these two, I mean, already huge amount of data analytics is put in two areas, what is called as, fault detection. Which node in the network can go faulty when what type of traffic pattern hits the network is a node likely to fail. In a similar sense, probably for the security threats also. What kind of pattern consists of a, say, denial of service attack, right? Or when can we say that a malware is passing through a particular part of the network? So using analytics, all these detection functionalities have already been in place from several years, actually, fault detection. But now people are not stopping there. Now they want to predict the fault. Right? When can a fault occur? Predict in advance and then take the corrective action so that there is zero downtime, so that there are zero attacks. So that's where the paradigm of what people are referring as, we want the networks to be self-healing and self-optimizing. Right? So that is being worked out using all the AI paradigms. So roughly by this year end, we are expecting about 53% of world communication network providers to have some form of AI in their network management systems. But having said that, I mean, it's still in its infancy in the area of communication. So what are all the other exciting use cases available? Probably we'll talk a little later. Thank you.
Thanks, Ratnakar. In a single line, it is like you are building self-organizing networks where it can heal and it can organize itself so that there will be zero downtime.
Right, that's right.
So thanks a lot, Ratnakar. Let's move to our next panelist. This view is very important, especially from the product management, who is not a technical guy, but we want to see how from product management AI is helping them.
Hey, thank you so much, Praveen. You're absolutely right. I'm not a very strong technical guy, although my initial years were all in software engineering. And once I usually say, once an engineer, always an engineer, no matter what you do in your life. So this topic of AI is very close to my heart for several reasons. I look at AI as a basic enabler for solving real user problems, identifying their unmet needs and using AI to solve for those. And I will speak in the context of smartphones or in general smart devices. There is a reason we call these devices smart, right? If you actually look at the Merriam-Webster definition of the word smartness, you'll find that it says somebody or something that can do several things at the same time with a lot of efficiency, which is what our smartphones these days are. They can do way too many things. We only carry this one gadget these days in our pockets, and it can do several things very, very efficiently. So that is why I call that these smartphones are born smart. Out of the box, they're very smart. But is that the definition of intelligence? When we talk about AI or when we talk about intelligence in general, my definition is that these devices become intelligent over time, right? Praveen, you and I, let's say we buy the same device. On day one, it will behave the same for you and me. After a month or couple of months, it would have learned that, okay, this device belongs to Praveen, this device belongs to Ritesh, and we are two different individuals. We have different tastes, we have different emotions. It all comes down to that individual, and can our devices adapt to that particular individual? And that is where I believe AI comes in and plays a very big role in day-to-day interactions with our devices, smartphones. If you start counting, you'll probably count hundreds of micro interactions we do with our devices. And how can AI learn from each of those interactions? And next time I'm trying to do something similar, it offers a very seamless, frictionless experience for the user, so that me as an individual have more time to do more important things in life rather than taking care of mundane tasks. I'll give you 2 or 3 specific examples of what from a product angle we have been trying to do at Samsung. Very common interaction that a lot of us have with our smartphones is we take a screenshot or we take a picture. Let's say I'm on Instagram and I take a I find something very interesting and I take a screenshot. I want to share that with my social circle. Sharing is one of the most common things you do after you take a screenshot. Now, I may not want to share that entire screenshot. It has my date and time at the top, number of notifications. It has a lot of text from Instagram. There are too many things on that screen. I only found that one picture in the middle of my screen as very interesting. Well, there are tools to fix that, right? You can go into edit mode and you can crop the image and then you can share it. But that's all friction for the user, right? The user is in that moment. And this is where a very simple AI can come in, and the moment you screenshot, the phone can realize what is the most hero region in that screenshot. It can suggest that automatically to the user, and with a single click, the user just extracts that and shares that. Very simple example of AI being used these days. Another example could be, we are doing tons of things in privacy. We are doing a lot of things in messaging. Keyboard is another example. We type a lot. In India especially, we have so many different languages we converse in. All of us use English for our day-to-day activities, but when we are chatting with our close and dear ones, we start using our regional languages for typing, Hindi or Marathi, Telugu, so many different languages in India. And you might have noticed that these days keyboards have started giving suggestions while you're typing a sentence. The keyboard will try to understand what the user is trying to type, and it will give you a suggestion for the next word. Now, where does AI come in, right? Many times if you're typing, say in Hindi, I use Hindi a lot, the keyboard will try to autocorrect it to the closest English word, right? That's a poor experience for the consumer. So at Samsung, what we have done is we have built an AI model where we can understand that the user is using the English keyboard. He's typing the English characters, but the words are not in English. They're regional language words. Understand that and do not autocorrect it first of all, and then start giving suggestions in the same language. So another very trivial use case for AI. Similarly, many other such examples that I would love to talk about during the rest of the session. But bottom line is, AI can really enhance the overall end user experience on our devices, and we have just scratched the surface so far.
Okay, thanks, Ritesh. To summarize, AI will be the prime enabler for personalization. That's the overall message you want to convey.
Yes.
Thank you. Thank you. Srivatsa, if you joined and you're able to hear me.
Yeah. Hello, everyone. Thanks. Thank you, Praveen. I think you set the right sequence, because it's always easy for me to explain after the product management that Ritesh has rightly set the context. So our primary focus is, like all of you know, right? I mean, a couple of years ago or even many years ago, AI exists. But how do we bring the AI to the specific devices? That's where the term called on-device AI, edge computing, is what I want to introduce. I'm sure all of you know about it, but how is it possible, right? So the use cases which Ritesh really talked about, and many more, which I will also touch upon, it is because of the computational advancement which is available on the edge devices. In this context, we'll talk about the smartphones. So the smartphones have a very good computing capability with GPU and custom neural processing units from different vendors. And also we have a very well optimized algorithms. That's the outcome of all your research, right? Whatever papers you submit, whatever various use cases you take it and then experiment. Over a period of time, it becomes very stable, can go into million devices. So by taking these two, what we started is we started trying to understand how a single approach, a single kind of deep learning or a shallow learning and specific models can be used for a various specific needs. Let's say when it comes to the smartphone, as end user context, right from 5-year-old to 50-year plus, everybody is my customer. I mean, anybody in this world will love to use the phone, but then it is very difficult, right? It's very difficult for different age groups. So as Praveen said, I think this is the time to bring some amount of personalization, some amount of on-device learning. So how is it possible, how we are doing and influencing the user experience is, let's say, an example of a search. Even though you have your smartphone capable to store lot many contacts, 5,000 plus contacts, maybe 10,000 images, various types of data exists on your phone, with the 64 GB is the most common, and you also put some MP3 videos and all using SD card. The difficulty comes when you want to search for something at a right time, right? So this is where we built an on-device search engine, which is as capable as today's you go to a web search and try to do it on a laptop. How do you retrieve your own information? And based on that usage and how you are using it, based on time of the day or place of the where you want to look for such information, we customize that. We understand, and that everything resides in the device. So that's where, even though I did not tell in the beginning, the on device actually brings you the privacy and also the reliability and also full advantage of the lack of bandwidth. Of course, Ratnakar is trying to build a pipe which can solve all the problems, but still in India and various country contexts, it is still a gap. So we try to address these things using the on-device AI.
Okay, thanks a lot, Vatsa. So to summarize, it's like providing the right info to the user at the right time, right? It will really impact the user. Okay, so moving forward, Ratnakar and Srinivas both used AI fruit. So there is a question on that discussion point to continue. So it's like this: has all the low-hanging AI fruit has been already picked up? Will AI advancement become increasingly difficult in your field going further? So let's start with Srinivas to hear his opinion, then we'll move forward.
Yeah, so interestingly, in the healthcare side, the AI as such, the assimilation is very low. I think we are not even talking about fruit. So if I have to use analogy, let's call it as cherry picking. We're still doing a very very cherry picking of it, because as I said, the first end user happens to be the radiologist, whom we need to convince, saying that the AI is indeed is going to help his workflow assistant. So at this moment, it is still there to pick up. There's a lot more opportunities are there. The proliferation of the AI is the last stage. I think in my domain, at least for the ultrasound imaging, is just trickling down. And the work which we have done so far, based in Bangalore, we are even talking about, not even talking about diagnosis. We are talking about, we have a very interesting 4D transducer, means I can get a complete visualization of the heart in 3D plus time domain. Well, I got a very good picture there, but the clinician also, it puts a lot more pressure on the clinician to find all the metrics or all the parameters which he needs to measure it to make an assessment, saying that is the problem in which particular wall. Let's not use a jargon here. So is a problem in the wall or not? To come to that conclusion, it requires a lot more measurement parameters needs to be done. So it requires a lot more knobs to be rotated and measured around. So the approach we are saying that I want to gain a trust, because we are talking about low hanging fruit or cherry picking here. So we have enabled the clinician to say that, well, I will find out all the 26 parameters which is mandated by you to make a comprehensive assessment. This will be automated for you. You just have to give me the 4D data. I'll find the right plane for you and measure the data and tabulate it for you. And what information you need to decode for that, it is for you to do that. I'm not playing God there. I'm just giving you an automated information there. So the problem as such in healthcare is that still it is very barren. So it is open invitation to everyone to join us. So it is a lot more to be done there. The field is still has immense scope. As I said, we are still doing a cherry picking there, Praveen.
Okay, a lot more to be explored, as you said.
Yeah.
So while you are explaining, I got my next question for you, which I'll come back after Ratnakar.
Sure.
Yeah. So as I mentioned in the previous round, so AI in the area of communication and networks is in its actually real infancy. I mean, I wouldn't even say whether, in fact, not even all the low-hanging fruits are picked up actually. In fact, probably somebody fed it in the mouth and only that was taken. No real effort was made to go and actually pick also, right? So the reason is this actually, because right, until the kind of accuracy is required for your prediction and classification, unless they are near certain, right, we cannot really take chances. Like for example, I cannot tell you that, hey, your call, whatever, if you make a call, I'm enhancing it with using AI techniques. There is 99% chance it will improve your experience. But there's 1% chance your call will drop.
Yeah.
Right. People don't want that actually. People want a certainty basically. Either it will go through or it will not go through. Right. So that's where probably there is whole lot of pickup is not happening in a lot of conventional areas of communication network. But the interesting thing is now the newer techniques, like because right, when the 5G is coming in now getting deployed, there are several things happening there along with 5G. Right, one is what people call it as edge computing, where you're bringing all the computing resources to the mobile edge, really, right? And also you are talking about what is called as a virtualization of the network, right? Network, you don't need this dedicated specialized boxes. Everything can be managed from a data center, right? All your network processing is happening in a data center. So if such is the case, if everything is a software resource, right? So then can I play something with that? Like for example, if I know that at this time of the day, my network will be loaded with 1,000 users, right? I'll probably light up 100 servers, but at an off-peak time, I'll probably light up only a couple of servers, right? It'll be a huge saving if I am the network operator looking at it, right? And I can err also. I mean, instead of 2, probably I can go with 5. I can go conservative and still get a lot of benefit from the operation of my network, right? So similar thing to do with the network scheduling. Like for example, today, if I have 10 users connected to the same network, right, everybody is getting the same quality of service. I really don't differentiate your context versus somebody else's context, the application you're using versus somebody else is using, right? So probably in future I should be able to do it. I mean, I am planning to do it, or we will be able to do it, when I know that, hey, you are playing a game, you need a low latency response, right? Whereas you are watching a streaming, you have already buffered data for next 10 seconds. So if I delay for you and give a scheduling immediately for the gaming guy, both of you will be happy, right? So that kind of play at the network scheduler level, is in progress, is already thought of, and these developments are in progress. And even at the very, very physical layer level, the wireless radio interface itself can actually be made a lot more intelligent. Like, to take one example, so today's network, how they work is, network sends some pilot symbols over there, right? My device tries to estimate the channel condition. How bad is the channel? How strong is the signal received? What is the noise in the environment? What is the interference? Everything it computes based on those pilot symbols, and it gives a feedback again to the network that, hey, this is the channel I'm seeing. So the network will accordingly allocate. There's a two. But for example, what if either the device or the network, if we can predict the channel condition and make our resource assignments accordingly, then it's going to be a lot more optimized. A lot of over-there signaling is saved. So like this, the examples are endless. In fact, the most simple case, like today, if you need to get a incoming call, right? The network has to page you, hey, where is Praveen, right? So now, should I page for you throughout Bangalore, right, and wasting the bandwidth of each and every tower in Bangalore? Or if I can predict that, hey, at this time of the day, Praveen will be available in this tower location, I'll page for you only in that location, and you'll get your call. I'm saving the bandwidth wastage in all the other 99% of the tower locations. So like this, the potential and possibilities are enormous. So that's why I see a great future for the role of AI in wireless and in wireless networks. And definitely, I mean, in the 5G deployments, there's only getting into as a side actor, but probably by the time we reach out to the 6G deployments, AI is going to be an ingredient in the standardization or the development of 6G itself. So that's my take.
Okay, thanks, Ratnakar. Actually, when I was when this discussion point came, I was really curious because protocol is more of standards and standardization, right? So as you rightly explained in the start, there is 0% margin error here. So how AI can adapt? I mean, AI can be an ingredient in the protocol and standards. So to start with, as you explained, in resource allocations and deallocations, it can play a crucial role. And of course, going further, we can look at the possibilities of 6G. Thank you. So let's move to Ritesh.
Yeah, thanks, Praveen. So talking about has the low-hanging fruit been picked? I would agree with all the previous panelists. We have hardly scratched the surface. I mentioned that earlier as well. I would say that not just in smart devices, smartphones, in all the AI fields we talk about, there is just way too much to be done, because just look around as a human, think about your 24 hours, or think about any normal 24 hours in any normal person's life, and how many tasks that he does which are enriching for that person versus things that he just has to do and they're not adding anything to his life, right? All of those latter tasks can easily be taken over by AI. Again, going back to the context of smartphones, I think Ratnakar mentioned about accuracy. Again, a very, very important topic when we always talk about AI. AI can be used to either suggest the right thing at the right time, or take it one step further. AI can also just take the decision on the behalf of the user. There is a very fine line there. What if AI gets it wrong, right? That's where the question of accuracy comes in. Your other question was about will it become more increasingly difficult over time? I think the biggest challenges will be to get to that near 100% accuracy levels. As long as we are suggesting something using AI, I think users are very open. They are more adapting. But if we let AI start taking those decisions on their behalf and we get it wrong, that is where we can get a lot of backlash. So as thought leaders in AI, we have to be very careful. Where is that fine line? How do we draw that fine line? We talk about AI as a self-learning, right? Tons of data, you train your models using existing data, and then you look for patterns, then you make some decisions. That's beautiful. That's self-learning AI. What about self-correcting AI? Let's say AI got it wrong. Can AI figure that out on its own without asking for any input from the end user? Because if the end user is telling AI that, sorry, you got it wrong, the right option or suggestion or task should have been this, again, that's too much friction for the user. We won't be able to scale that model. Can AI look beyond what it was trying to do before and after? Let's say AI took a decision and it turned out to be a wrong decision.
Mm-hmm.
Can, first of all, AI figure out that user did not like that decision? And then go before and after. What happened before and after? What did the user do immediately afterwards? Right? This is something we call advanced learning. As you know, we are working on that. Can AI figure out that, oh, the user intended this and not that, without asking the user?
Sure.
That is where the biggest challenges will come. And we are doing a lot of things in this area. A lot of focus is going in the area of developing newer and newer use cases. I would say equal amount of focus should also be going into improving the overall accuracy of the output from AI, and by employing a self-correcting or a self-healing model, and not just a self-learning model.
Okay, thank you. What's your view?
Yeah, I think to me, AI as a technology, right? We put the seed a couple of years ago with a lot of effort from again research. And if you look at how that can expand, that's where the applied AI comes into the picture. How it can enter into various fields and how it can make its own impact. In that, one of the key element what we are need to focus is also the data. When it comes to the applied AI, we have seen a lot of advancement in the NLP area, Praveen, computer vision area. But when it comes to the day-to-day usage, how that data which matters for these algorithms to do better at a highest accuracy and what and all we talked about. That's where the challenge comes into the picture. And look at the devices like a smartphone or any edge device in future. It needs to accumulate all these various AI technologies together and still perform at the level of end user needs. It could be a personalization, as Ritesh said. It could be self-correcting. But how is all this possible, right? That's where we need a systematic platform approach, I would say. And working these various deep learning or shallow learning techniques together to provide a common user experience. I think that's the direction. And we are just in the beginning of that when it comes to the realizing the real user needs and solving the problems, because we also don't know where user can accept and where he will not accept.
Right.
We can't force it, but yeah, so we can't force it, and we don't want him to remember and then give a separate instruction or a command. We want that to be part of his day-to-day life. I think that's where we are aiming at.
Okay, so as you rightly said, there are some fields where there is a full data is available. Of course, how do you tap the data and improve your algorithms over the time, then go for prediction. And also a decision has to be taken or not, that is still debatable, as Ritesh and you are saying. So we can go in that fashion. But there are some fields, especially I want to talk to Srinivas, right? Where in a medical field, there is a lot of lack of data. Especially one of my friend was working with Philips. I think Srinivas might be knowing, Jitendra. So
Yeah,
for 1.5 to 2 years, he was running behind the hospitals to collect the cancer data. Okay, just to make sure that to take that data and model it and based on this algorithm and test it. So there are some certain fields where getting the data itself is a big challenge in especially medical field, because of privacy concerns or different factors, right? So how do you see that the advancement can happen in those conditions? Like let's take example the current COVID, right? Did you see that in the medical side whether deep learning or AI is able to help COVID in certain aspects and take it advancement? What's your opinion, Srinivas?
Yeah. So Praveen, you asked me two questions about the lack of data and the challenges one faces to get the AI solutions. And you also asked me about how in the COVID-19 scenario, how things are being done now. So let me take the COVID-19 part of it first.
Sure.
So as someone has rightly said, I think it's a Churchill or someone who said that never miss a good crisis. Looks like either the COVID has found the right time to come, or maybe I'm just cynical here. But interestingly, the COVID pandemic as such has brought a lot more global research labs. It could be even the genetic ones, the drug, pharma, imaging, and also even the device providers, caregivers, under one mode of collaboration. I think that is very evident in to observe. I think even the person who is not into the drug discovery and all, one can observe that there's a lot more collaboration is happening. If you see that, to give a context, exactly last year in the December time frame, on the 17th of December, if I have to quote, we have seen the first case of the COVID. And today we are talking about COVID vaccine being rolled out to the people. I think never in the history of mankind such kind of a thing has happened. I think the last vaccine which was released in such a record time span, if my memory serves well, was the mumps vaccine. I guess in 1963 to 67, in 4 years record time, a mumps vaccine has been bought for the children to come out of the polio and the other things, stuff like that. So coming back to the context again, so COVID-19 has indeed interestingly solved a problem, saying that the way for finding a solution is collaboration, sharing the data across the labs. It is like across geographies also you have seen the data being shared. So at least from the imaging point of view, my take was that I've seen in the public domain all the data properly annotated and being shared without any qualms. Of course, data being completely de-identified, anonymized, but for the purpose of finding a very efficient screening device. We at Philips in Samsung also made an attempt to find out, saying that in initial stage where we have lack of data, can I make some kind of a screening device where it has got a high specificity? Because I really don't have a data of the COVID patient, but I have a data of lot more normal patient. So at least can I solve the problem of bottleneck in the care part of it, where only the right person will be advised to go for a RT-PCR test, again a jargon here, but it means a genetic screening test which costs money and time. So only the intended persons will go for this one rather than rolling out for everyone. So the access to the data during COVID has really enabled to come out with this kind of screening device. Though it has a lot of lacunae, gaps are there, but it did help the in streamlining the care part of it. And coming to the part of not having a good data, we do face the challenge. Let's say, to cite a proper example, the prostate biopsy which we work requires a prostate cancer data, and one needs to roll out that feature in record time, let's say in 2 years time. And we need to have a very good data spanning across all age groups. But the hunger for data is always there. So the techniques we follow is that lot of transfer learning also we do. We can even find some kind of similarities of the cancer genomics across other imaging side, and we try to gather that kind of information and try to make the model learn more interesting information from the heterogeneous data. Actually, I'm rolling out a feature for a particular Samsung device, but I can get the information from other devices also and try to make it more robust. So there are a lot more augmentation techniques like that, by way of transfer learning, by way of hybrid learning, where completely orthogonal anatomy. It is nothing related to the prostate. The prostate is an organ in the human, but we can take it from some other, say, liver, and still can find a signature there. So these kind of techniques, we did find success there, and we did publish papers on that, and we have success like that where we can still mitigate this data paucity or scarcity there.
Okay, thank you, Srinivas. The next question is about on device to Srivatsa. So in his talk, he has very clearly highlighted the on device can help in privacy and as well as in reliability, etc. So this question is about how you can teach even for on device AI. What about the AI ethics or social norms for a AI product? Let's take an example of social robot. So it was launched and so suppose it is launched in future and it is taken into home. Every home has its own perspective, right? So the social norms what we adapt in our families are like, say suppose if you are in a home and parents and a kid got backlash from their parents and he went and shut off the door and he was staying. Somebody visits our home and if the guest asks about where is Rohan, right? Say suppose that's the example of that kid's name. So parents will tell that so he is studying, like that. They will lie, but it's okay to make sure that there is nothing wrong in the family, because these are minute incidents. Now, if we take a social robo and it will observe everything what's happening in the family. Now, if a guest comes and if the guest is talking to social robo and he says, "Where is Rohan?" So it doesn't know what to tell. It will tell what it has observed. It will start telling that the parents scolded Rohan and Rohan went and shut off the door, like that. So how do you get, see, every family is different, every culture, every ethnic culture is different. So though you are protecting that privacy, this social norms or ethics, how you can incorporate into robots or future AI products, so that this kind of issues can be tackled.
Yeah, I mean, this is a great question, Praveen, because you are just touched upon the core part of the intelligent autonomous systems, right? How do we teach ethics to them, right? So if you look at, I mean, still the current on-device applications are still focused on solving a specific need. While we cover horizontally, it is going to address your specific needs when it comes to the user's interaction with the device. But the AI ethics and how do we apply that to a robot kind of a product is still a research field. To my knowledge, I think in 2016, government, society, researchers, philosophers, psychologists, everybody come together and they try to define, right? So here, I think broadly divided into two areas to put it simple. One is like, who are the designers of these robots, right? These are the researchers, engineers, designers coming together, and they are trying to create or mimic a personality there. It's like moving away from the applied AI towards a general AI, like a human brain, like kind of a philosophy. So how do we realize that? This is where I think the larger portion of work has to be done together by the set of people, starting from researchers to the device makers to government policies and everything. And how do we actually take every aspect of technology plus society plus every home scenario into the picture? This is where I think a lot of thinking is required. Let's assume that once we achieve that and we put it onto a device, let's say we have a beautiful robot given birth and it can talk. Now, again, I'll come back to the data portion, because if you look at even today, the most advanced facial recognition engines from very world #1 corporates is still gender biased.
Right.
It still has a gender biased problem because we have trained the data like that. So the challenge remains, how do you actually anticipate and keep training to a human-like robot to behave in a certain way? So the second part is, once we create that, how it can decide, right? So there is nothing like a rule now. If person X is there, only say this much. If person Y is there, say full. There's nothing like that. It is like the intelligence should be really spontaneous. I mean, the robot should understand that a newcomer is there and Rohan is my family member and I shouldn't say this or I should say this. I think we are not yet there, and it is a work happening. And I see, I mean, even within your own team, and we work together to build such a prototypes, and that can behave to a certain extent. Again, target to a use case, but not like a everyday environment. that is still, I think, a work for us and for next generation also.
Okay, thank you. So the next question, discussion point is to Ritesh. We spoke about again on-device AI and privacy reliability, but there are some certain number of products, like say suppose if it is a smart glass, right? Everything you cannot put the complete processing, everything on the device itself, because of different reasons, the power or the size or the form factor, etc. That's one problem we have. And the second thing is when you are wearing a smart glass, right? So obviously the privacy of the users, of the other guys, the other parties will come into picture. So in many cases in California, when Google also launched smart glasses, it got banned wearing in bars, etc. So in these conditions, right, how I mean, as a product manager, how do you want to sell this product? How do you promote this kind of products?
Yeah, Praveen, that's an excellent question. Behind every such business decision, we have to again go back to that, what human emotion is driving that decision, right? So when we talk about privacy, very interesting and very touchy topic, very private topic for a lot of folks. In fact, the definition of privacy will change depending on who you are asking, whether it's a Gen Z versus a baby boomer, whether it's somebody in the West, US versus India. I mean, probably in US, privacy of data is extremely important. In India, we conducted a survey where people were more worried about privacy of space. So before we go deeper into this, let's try to understand what are those human emotions at play here. To me, there are two emotions at play. One is fear, and the other is trust. Fear because people are worried. Nobody wants their data to be leaked and to be used for nefarious purposes. And nobody wants their private space to be invaded, right? Trust, or rather lack of trust. I mean, there have been several examples where, that trust has been broken over and over. So many companies these days are extremely careful about how they are defining their privacy policies, what type of data they are collecting, how will they store that data, what will they do with that data, how will they destroy that data. So privacy has been, the topic of privacy has been around for a very long time. When it comes down to how do we solve for that in an AI-based scenario, especially things like smart glasses, let's go back to the value that these types of gadgets are adding to a consumer's life. We have to remember that consumers are very smart and very naive at the same time. It's a conflicting statement. They are naive because many times they themselves don't know what they want. They don't know what their unmet needs are, right? Unless a solution is brought to them. But they're also very smart because you cannot impose things on them. Unless you're giving them true value, you cannot force adoption of any product onto them. So any AI-based gadget, if consumers see value, not the ones who are using it, but also the ones around it, and that value is communicated to them very clearly in plain English or plain language rather than techie language, first of all, they will feel a little more comfortable with it, right? Okay, this is something that is adding to our day-to-day lives, bringing value to our day-to-day lives. Second, all corporates who are thinking about bringing AI-based gadgets to the world, they have to be extremely transparent to the rest of the world about the type of data they're collecting, and what are they going to do with it. Like all the things we talked about, how are they going to store it, what if there is any misuse, or shut down all avenues for misuse of such data. Honestly, there is no silver bullet, Praveen. Everybody, this question has been on everyone's minds. You know, you rightly quoted the example of Google Glasses. I remember about 6 years ago, I was at a startup in California, and those days we had a small office, and in the afternoon we used to start playing cricket in the office. We had one bat and one ball. Okay. And we would just start playing cricket. Our CEO was based out of the East Coast, Washington, D.C. So he was not in office most of the time. So we'll take the afternoon time and we'll start playing cricket. And we did not know that one of our employees had gotten a Google Glass. And she was also just watching us play. And a couple of days later, this video was floating in our small company of us playing cricket. And it was all in good fun. Yes. You know, everybody appreciated. Our CEO was very happy to see that, you know, employees are having fun. But it was recorded without us being aware that it was being done, right? So these types of examples where the overall purpose of why the gadget is being used is very clear, and it's in the longer scheme of things, it is for the goodness of society. Right. Consumers will totally get it. Right. So this is where everybody needs to create that awareness, and this is the time when we have to start doing that. Yeah, I remember one incident when US launched first time this cameras capturing that people who jumped the signals. So there was one issue happened. So it captured that person who crossed the signal, and it sent that picture to his home address. Then his wife saw that picture and found that he was with another woman in that picture while he was drawing. So he sued the government, and of course a lot of things happened. Then they masked, etc. But ultimately there are learnings which will happen, right? The technology cannot go back, it will advance, but we'll find a way to address that. Okay, thank you with that. And the next discussion point is to Ratnakar. Mainly it's about since this AI advancement will happen through learning ourselves, or AI itself will learn and it will become more autonomous, right? Does government laws, I mean, will the government laws also has to keep changing? One example I can quote is, say suppose now you have an autonomous car and it is self-driving and you are sitting in the back seat. Now if it hit the pedestrian by mistake, right? Who has to be sued? Either the car itself or the car manufacturer or the car software provider or the owner who is sitting in the back. Who has to, I mean, be sued? So there are a lot of laws currently in the countries which are specific to the person, not to the autonomous AI. So what's your opinion on this?
Yeah, quite interestingly, I mean, a few months back when a driverless car article appeared in a magazine. So I asked a similar question to my 10-year-old son, actually. I see. Hey, this is this cool driverless car. But imagine what happens. I mean, it goes and hits a pedestrian. So who is at fault? I mean, the car owner, car manufacturer, software developer. And he simply said, no, the pedestrian is at fault. Why did he come in front of a driverless car? Okay. So immediately said, hey, that's the most politically incorrect answer. I mean, that's not the way the world works, right? It just came to my mind when you referred to that example. Sure. Yeah, this is actually a real question, because in the sense we all agree and acknowledge that AI will do a lot of good to the world, right? Like for example, most of the road accidents, people say 90% plus of the road accidents are because of a human error. Right. In that sense, if AI can really pitch in and eliminate all those accidents caused by human errors, then actually world will be a much better, much safer place. The roads will be a paradise, right? So But now the question comes, so then what about the rest of the 10% of the things, right? Where AI can genuinely go wrong, right? Or because of the biases or insufficient data, right? It can take a wrong decision. So that's where I think we have really a long pole or a long path to actually adapt a lot of these things as a mainstream technologies, because you still have several players in this game, right? Like, for example, if AI is deciding the behavior of a car, there are sensors feeding it all kind of things to the AI, right? The sensors could be wrong, faulty, right? And then sometimes the data is being sent to the server and some input is coming from the server, right? There could be lag and latencies in the network.
Right.
And then of course the algorithm or the model running itself could be faulty. And then add to this the complexity. For example, if two AI cars collide, right? You have where two different models running. So fixing a blame or fault on somebody, I think really needs a higher form of intelligence actually, right? Which is intelligent and leads to AI, right? So that way, these are not simple, but I already know that, I mean, this car industry has already recognized. And in fact, I saw American Bar Association. I mean, they are having regular meetings because it impacts several industries, not only automobile industry, it impacts the insurance industry, for example. Yeah, it impacts all the road, laying out the roads, all the infra planning. I mean, there are so many implications bringing in such a sensitive domain. So, but yes, definitely laws will be required to regulate, so that I mean, Shiva's already mentioned what kind of biases can creep into AI, right?
Right.
So that way, if left on their own, I mean, I can create AI which completely will benefit me, but it's destructive for all others. So that's where a strong regulator will be required for this industry, and there should be common standards and common guidelines which everybody has to adhere, and there should be a minimum agreeable, tolerable error rate, which should be adhered by everybody. So I think those regulations have to come in. Only then this can really see the light of the world.
Okay, I 100% agree with you, Ratnakar. And yeah, so we are almost down 1 hour. Thanks a lot for all the panelists, Ratnakar, Ritesh, Srinivas, and Vatsa, for taking off your busy schedule and attending this panel discussion and sharing your view, how the real world is solved and how the future and what kind of challenges, what kind of modifications are required, not from AI perspective, from overall perspective. Thanks a lot again.
Yeah, thank you.
Have a great day. Bye.
Thank you for the
Thank you.
opportunity. Thank you.
Have a great day. Bye.
Bye.
Thank you.
Bye, everyone.
Bye.
It was really insightful to hear the thoughts from industry expert leaders. So thank you, Praveen, Ritesh, Srinivas, Srivatsa, and Ratnakar for providing us with a very deeper insight on real life challenges and future of AI. So with that being said, let's move to our next topic. So it will be a technical paper presentation on the topic named Optimized Web Crawling of Conversational Data from Social Media and Context-Based Filtering. So over to the author to present it.
Okay, thank you very much. So I'm going to start my screen share.
Sure.
So yes, so this is optimized web crawling of conversational data from social media and context-based filtering. Let me just. So the authors are Dr. Rajeshwari, Dr. Annapurna, Dhanush Reddy, Jugal, Kirtana, Gaurav, and Mir. And the authors are part of this call. So the agenda is multi-tone dialogue, system requirements and planning, design of a web crawler, implementation of a web crawler, and result analysis. So introduction, real-world data is a necessary part for training system models, especially in cases of deep learning models. Conversational agents require large amounts of information. A web crawler is basically a bot that browses the World Wide Web, which helps in retrieving information from websites such as links in web page, URLs, and meta content. Problem definition. The development of a web crawler that scrapes conversational data from multi-turn dialogues from multiple social media websites. The current methodologies that are present today are depth-first crawling, targeted crawling, PageRank, and the proposed methodology is context-focused crawling, efficient crawling techniques with text classification, and topic-specific corpora. So building chatbot requires a large amount of conversational data. In this paper, a web crawler is designed to fetch multi-turn dialogues from websites such as Twitter, YouTube, and Reddit in form of JSON format. Tools like the Twitter application programming interface, the LXML library, the JSON library are used to crawl Twitter, YouTube, and Reddit to collect conversational data. The data obtained in raw format cannot be used directly as it will only have text metadata such as the author, name, time, or provide more information on the chat data being scraped. The data collected has to be formatted for proper use case, and the JSON library of Python allows us to format the data easily. The scraped dialogues are further filtered based on the context of the search keyword without introducing bias and with flexible strictness of classification. So the system requirements. So we used a Python and a Scrapy framework, as well as a Selenium framework to implement the crawler. A NoSQL database was used to store the conversational data. The Beautiful Soup was used to parse HTML as well as XML documents. And LXML was used also to parse HTML elements. So these are a couple of research papers we use in our literature survey. A full set of the research papers we've used is present in the references towards the end. So this is the basic UML diagram that we used for our crawlers. Although the system architecture for the three crawlers we developed specific to YouTube, Reddit, and YouTube are slightly different. This is a general system architecture we followed. The unvisited URLs are added to the URL queue. The web page downloader fetches the URL from the URL queue. The web page downloader downloads the pages from the internet. Parser and extractor extracts the conversational data and hyperlink URLs from the downloaded page. Relevance calculator calculates the relevance of the page and assigns a score to the extracted URLs. Topic filter and analyzes if the extracted conversation data is relevant. If it's irrelevant, it ignores the irrelevant data and it's removed from the queue. Then finally, the relevant conversation data is added to the database. We add the extracted URLs to the URL queue and we report to the user. And this works in a loop where it goes back to the new URLs which are present in the queue and it repeats the procedure. This is the DOM model that's followed by the social media sites. This is a DOM model that's followed by the YouTube as well as the Reddit web pages. So Twitter crawler. So Twitter crawler, we use a streaming API to access to crawl as well as collect a random subset of public tweets. The tweets were crawled in real time, and the tweets could be filtered with geolocation to crawl tweets with respect to a specific region. These sample of public tweets was stored in a JSON file. This is a sample tweet that is crawled by the Twitter crawler. Steps to crawl the tweets with replies. In an effort to collect conversational data, we try to filter as well as crawl and make a conversational data set. So we filter to the collected public samples of tweets to find specifically tweets with replies. Finding the same by checking the in reply to status ID attribute of the collected tweet. We'd crawl the parent tweet using the in reply to status ID. We'd output the parent as well as the reply tweet together in the JSON file. Next, the quoted retweets. To crawl the quoted retweets, the algorithm we followed was we would filter through the collected set of public tweets looking for quoted retweets. This was achieved by parsing the collected tweets and searching for the quoted status feature. The parent tweet is contained within the quoted retweet inside the quoted status attribute. We'd output the quoted retweet with its contained parent tweet to the JSON file. I'll hand it over to another author, Dhanush, to take over the presentation. Tanush?
Yeah. Thank you, Gaurav. Okay, so I'll be talking about Reddit crawler. So Reddit is basically an social network used for communities based on people's interest. So we have tried various methods for Reddit, like using Scrapy, using the Python tools and the Selenium to work on retrieving the comments, and it was not optimized. So it used to be like very time efficient because Reddit is in JavaScript, it's a server running page, and and yeah, it proved to be like to retrieve certain like 1,000 comments, it would take at least like more than a minute. So we started some research into Reddit and found out that Reddit actually supplies this data in the form of JSON. So we took the initial request, like what we want to crawl, and appended with an .json, which would actually retrieve the entire JSON of the Reddit. So this JSON file would contain the raw data of the comments. So there would be like links to the comments, so which we can crawl through and retrieve the multi-turn dialog. So this method has been very efficient in the terms of retrieving very quickly. Like the 1,000 comments, which took earlier was about 1 minute, could be done in less than 30 seconds. So this is the Reddit crawler. Can we move to the next slide? Okay, YouTube crawler. So here, YouTube crawler, the algorithm we chose to follow was initially we initialized a new session with a user agent, and we retrieve the YouTube page with the initial comments. So now what happens is, since YouTube is also a server-side rendering page, you should be, so we first worked on Selenium. So what Selenium does is it brings the entire web browser to your web driver and starts loading it in the backend side of it, and loads the data one time at like one page at a time. So which again proved to be inefficient. So when we looked into the YouTube, what YouTube does is it takes it makes an AJAX request to the server. So when it does, it renders certain component of it which needs to be changed instead of rendering the whole page. So if we scroll a little bit down, the comments would be more comments would be available to us. So that is done using the AJAX request instead of the whole web page loading, right? We just make use of this AJAX request. So that is what has been done for the YouTube crawler also. So instead of us trying to retrieve all the comments at the same time, we make an AJAX request one time at a time, so that we can retrieve all the comments just as YouTube does it with their server. So we hit the endpoint and get the replies. So this is all of this is stored in an JSON file format. So this is how we implemented the Reddit and the YouTube crawlers. Can we move to the next slide? Yeah, so this is the JSON data that we retrieve from YouTube crawler, where you'll have in text, you have time, you have author, and the CID. So the CID is the one that is used to refer, like, which comment it belongs to, and the reply would have an parent CID, which would point to its parent comment. So we have structured all this data which we collected from the Twitter, Reddit, and YouTube into one single format, where we stored it in a hierarchy order of the parent ID and the reply IDs. Okay, can we move to the next slide? Okay, this is the common format. So the common format would include the ID, and it would include the likes, the number of likes the comments have got, and the replies. The reply would have an RID, that is the reply ID itself. And then it would have the number of reply likes and what is the content in the reply, and the user. So all this has been made sure that, because there's a lot of comments, right? So some of them would be irrelevant also. So all of this is taken care in our project, where we managed to retrieve our data based on our needs, like what topic do we need. Suppose if we need an automatic car system topic, we could search for that particular link and get the comments for that, and limit the comment size also, so that you won't be buffering too much data. As per our needs, we can get the data. So now we'll go to the application part of like how we would get our data as per our need. Can we move to the next slide? Okay, comment filtering. So one of my teammate is gonna take up this comment filtering.
Hello, can you hear me?
Yeah.
Yeah, right. Okay, so comment filtering here is like, so basically the requirement here was just that if given a topic, they wanted like a quick and how do I say, like a quick solution that wouldn't require too much time or like resources in general. So when I try to explain like what a kind of like conversation is on social media, it's like usually there's one main comment and then there are a bunch of replies to that comment, which start with like the key topic, which is the central part of that whole conversation. And then it is like it starts deviating as time goes by, because like any conversation in general is supposed to like, it's sort of like time series data. It starts at one point and then it ends after some time. So in the beginning, you have like the main topics, and then like people tend to come back to the main topic, and then here and there, like especially on social media, you'll have people who randomly post ads or randomly post, like obscenities or random things, and then like here and there they will say like follow my page, all of that. But for the most part, they tend to like stick to the conversation, right? So how do you retain like that essence of that conversation and remove all these extra things that aren't always occurring, but here and there they will occur? So what I did was, we like not what we did was we tried to like um, figure out. We used frequency as the metric, right? Because we didn't want to use or like predefined like data sets or anything, or like bring in any kind of bias. So the only like if any bias that does happen is like from the data set itself. So if people have been essentially talking more about, say, if the search term was cancer, and like if they've been talking more about, say, cancer, injections, carcinogens, all the content associated with those key terms that have been recognized as frequently occurring will stay, and all the terms that seem to have no relation to whatever's been frequently spoken about will be removed. So frequency is our metric, as I said earlier. So can we go to the next note? I mean, next slide. Yeah. So as I was saying earlier, like one of our our two main goals are to remove things like ads, AdWords, publicity links, and unrelated comments that aren't associated with what exactly we're looking for. And we wanted computational efficiency, and there is no metric that you can use where there is like a predefined dictionary or something, because like all of these terms, especially on the internet, their meanings tend to change quickly, and a lot of times it's not the how do I say, like the grammatical dictionary meaning itself. So like if you talk about things like pollution, right? Online, if you just go by dictionary terms, it will just be things like pollution, gases, this, that. But say like there's been like a lot of smog creation in Delhi, and like you're at the time accessing like information around people who are from Delhi, and then you search for pollution, a lot of things related to things that are very specifically around Delhi will show up. So if you're going to train the chat box to deal with, say, like the audience from Delhi, or like around that state, you want the meanings to understand, like even if it's not like a dictionary meaning, you want that model to be able to understand what these words are like, and not put in our own bias. Like, so in that sense, we just use frequency as a metric, and not any of these other things. And we can like change our levels of strictness that we use to consider these frequent terms, right? So I will explain on the next few slides. But yeah, so this is what our model does. Next slide. So as I was saying here, so the basic, if I had to like start and explain what the algorithm does is, of all the data that we have, we take, say, like the first 1,000 comments or the first 1,500 comments, based on how generalized you want the selection of accepted comments to be. So if I take 1,500 comments, the likelihood that my model will be more lenient is higher, because there will be more like it gives the model more chances to pick up more frequent terms. And if you pick a smaller data set, like to calculate the frequent terms, like again, it will become very narrow to like how much data you end up taking to pick the frequency term. So if our crawlers take out say 10,000 comments, and we use the first 1,000 or 2,000 comments to make the frequency terms, like 1,000 will give you like a narrower data set, and like 2,000 will give you like more comments that will be accepted. And then the next thing that we consider is the frequency number that you want to take. So what we did with this model is, since it's all online, things like hashtags and @references are like usually very important comments, in the sense that especially with hashtags, it's because they have keywords, right? These are search terms. So when you put it in your like search comments, they tend to like link you to a lot of similar data. So if you're using a hashtag in a comment, like you give it, instead of like just counting the frequency once, you add some more frequency points to it just to give it more reference and make it like a more important term in terms of, you know, calculating the high frequency or the relevant terms. And then therefore, when you say like with once you've given all those calculations, you can see that the next value, wait, alpha earlier was the size of the data set. Like I referred to that value as alpha. I forgot to say this. And beta would be the term that we use for like that occurrence frequency. So once we go through those 2,000 comments or whatever that we have selected, so it's like from that you get those high frequency terms. So minimum, if it has appeared 6 times, then you put it in the list, meaning it becomes more lenient. Lesser the beta value, the more lenient the system is, because you're saying this word needs to appear only 6 times in that selection data set for it to become a frequent term, and we use that to, you know, validate the whole data set. So in that sense, if beta is a lesser value, it means that the word only needs to appear 6 times, so it's a more lenient number. And if beta is 10, it means that it's higher. As you can see in this table, I've used green to indicate like numbers that are increasing and red to indicate numbers that are decreasing. So when you see that alpha is 500 and beta is 6, let's take that as our first case situation, and we have a couple of values here. So the frequency terms that we got 372 frequency terms after cleaning, after removing things like stop words and all that. And then under accepted comments, you're having 1,056 and rejected comments are 44. So the next case, we increase our alpha to be 1,100, which makes our system more lenient because you're taking more comments. So you can see that the frequency terms like dramatically increases to 828. And therefore also like the accepted comments, we found only like another 40 approximately accepted comments, but then you see that a few more words like actually affected the data sets and made it a little bit more lenient, and the rejected comments got lesser. So in the next case, when we see that beta became 10, it means that the model became stricter, because we are saying that a term has to appear 10 times in your selection data set for it to be considered a high frequency term. So the number of frequency terms dramatically reduced from 372 to 96 here. And then you can see that the accepted comments also like reduced to like 1,002. So here we can see how the alpha and beta works. So using that, we can have like a different level of strictness or change it based on how much data we are able to retrieve and how much data we want, and how generalized we want like our data set to be based on the terms we're looking for. And we're not introducing an external bias. If the data has some kind of bias on its own, say like very location specific data or whatever it is, and if it is terms that are not just defined in the dictionary or whatever, it will still be accepted in our model. It's not like just grammar based. It's just based on whatever lingo that is being used in that conversational data. That lingo also gets like carried through with our data set here. Yeah, the next slide. Yeah, so this is just like a summary of what I already previously explained. Just clean and tokenize the data, and then make a smaller selection, and then create the high frequency term list, and then use that to evaluate the rest of the data. If it contains a high frequency term, we keep the sample, and if they don't, we reject that sample, and that's how you get your rejected comments. Yeah, next slide. In this way, yeah, so this is also the explanation of alpha and beta. As I said, alpha will be the size of the data set that we take for sampling, obviously it has to be lesser than all the data that is collected. It can be some whatever percentage of the total data set. It depends on, like, again, how strict you want the system to be. And then occurrence frequency is the term that we're using is beta. So here it means that, again, if you want the term to be considered frequent only if it appears that many number of times, using that you can, like, again, change the level of strictness and how specific you want, like, the selection to be, depending on the topics and depending on how people comment. Like, it does require some amount of studying, or like it depends on, like, the usage or the requirement basics over there, but that's it. Yeah. So given that, yeah, this is my this is our model for the comment filtering. Thank you. Oh yeah, this is the next slide. Yeah, this was just like an example slide that we had for, say, like the key search term pollution. Listen, Dhanush, Gaurav, do you have the slides for the examples?
No, this
Please wind up in another 5 minutes.
Okay.
Okay.
Okay, we'll
Okay.
wrap it up then. Yeah.
Yeah, we're done then. It is just examples, like slides that we had. Yeah, it doesn't matter.
Okay. Thanks, Kirtana. So this is our project. So the proposed crawlers were able to fetch multi-tone dialogues from different websites like Twitter, Reddit, and YouTube to maintain the quality of service and fast and relevant accessing, reduce response time, and improve productivity. It's necessary to design the crawler that can be a hybrid one and serve diversified purpose by applying threading and rapid text mining using AI tools. So these are the references these are the papers that we referred to. So yeah, this is our project. Thank you very much.
Okay, so let's wait for some questions, and if there isn't any, then we'll move to the next topic.
Sure.
I will answer that. Actually, there is, like, no noise per se. So it's just random conversation data that you, like, there's no bias at all when you're crawling. Like, you just go and obtain the data from online. We didn't have such a thing, like, we didn't measure anything like noise at all. There was only, like, a latency issues here and there, which we tried to minimize. That was the crux of, like, creating our own web crawlers for these. However, again, the noise in terms was, like, not noise per se, like, based on the search term, we did some comment filtering, which is what that comment filtering algorithm was for, to remove any content that we found which would be irrelevant for any kind of model training on that data set, which was the purpose of the whole project. So yeah, that is it. Like, we didn't have anything such specifically as noise. It was just like unwanted content in our data that had to be removed, and the removal metrics was what we just previously explained.
Sure, thank you.
Okay, thank you, everyone.
Sure. So now let's move to the very interesting topic. The topic title is Discovering Subtle Information from Text Using Bayesian Models, and it will be presented by Dr. Mrinal Kanti Das. So to introduce him, he is a holder of dual postdoc, so one from Aalto University, Finland, and UMass Amherst, USA, and he's also a PhD from ISC. He is also a founding member of ML Group and Center for Research and Education in Data Science at IIT Palakkad. His fascination is to develop simple and novel mathematical models to address interesting and challenging practical problems. His interest area includes topic models, Bayesian non-parametric, differentially private Bayesian models, Bayesian deep learning, etc. So let's welcome Dr. Mrinal to present this topic. Welcome, Dr. Mrinal, and over to you for the presentation. Thank you.
Yeah, thanks Ranjan, wonderful introduction, and thanks organizers for giving me this opportunity. So I'd like to share my screen for the presentation. So are you able to see my screen?
Yeah, we can see your screen, but I'm not sure if the video is playing because I'm on phone.
Yeah, I'm able to see
Okay.
Dr. Mrinal and Ranjan.
Cool. Thank you.
Okay, okay, great. So before I start, so I would like to say that feel free to stop me at any point of time and ask any kind of question. So I'll be happy to answer anything. Okay, so just feel free to have it like an interactive session. So let's get into the topic. The title is that discovering subtle information from text using Bayesian models. So many of these terms are known to you, but some of the terms have very specific meaning in this context that I'll explain. And so the outline is more or less like this, that first I will explain what is subtle information, and moreover, why should we care about it? What is the challenge to discover this subtle information, and the techniques to discover this subtle information, and what are the exciting use cases of subtle information? So this is the story around this subtle information. So I generally follow this pipeline. So like this, what is a real problem, then analyze the problem and get to the theoretical problem, and then try to solve it, then develop some technical solution, and then bring it back to the real life and validate on the real life use cases. Okay. So more or less, this will be the story. So let's first start with understanding the context. So this is the context of information retrieval, but unlike any very general information retrieval like question answering and those kind of things, this is more of a exploratory search. So what we mean by exploratory search is that the users often do not know what they were looking for. So they expect something that is there in mind, but they are not able to express it using keywords. So, but they like to explore something, and probably they will find out something very exciting at the end. So this is the context that we are working in. So this is quite contrastive to normal Google search kind of paradigm, and where people generally know what they're looking for and they have their keywords, all those things. Okay, so we are in the world of exploratory search. So in that context, what is subtle information? Okay, so text is the main thing that you're talking about here, but the method, I mean, I'll show you at the end that it can go beyond text, but okay, let's just focus on text here. So it is the presence in the document as well as the corpus is rare. So that rareness makes the thing subtle. So the dictionary meaning of subtle is difficult to detect. Okay. So this rareness makes it difficult because you might be hearing lots of time that frequency and those things in the talks, the talk before this and also in the morning sometimes. So because the techniques very much depend on this frequency and their prominence in the corpus. So here I come up with this challenge that if the frequency is not that prominent and the presence itself is rare, then how do we get this kind of information? Okay. So there is a illustration here of subtle information. You see that there are some points here, and we want to cluster this point. Now there are various kind of clustering. So look at the the second figure where you have two clusters, red points and blue points. But in figure 3, you have three clusters. Okay. Figure 4, you have some more clusters. So which one is correct? So many times we do not know that which is correct, because sometimes if you split it too much, you will get a noisy clusters. And sometimes the big clusters dominate some meaningful small clusters. So they capture this thing. So this subtle information is kind of this small cluster. For example, look at this green cluster in the figure 3. So in actually in the most of the standard techniques, they will give the output which is in figure 2, which this big blue cluster actually captures this small green cluster, and it becomes very difficult to detect this kind of small green clusters, but which might be very important and significant. Okay. Now let's look into the context of text. So this is the review article of Google Nexus 7. So this review article has around 1,000 lines of state, 1,000 lines in this review, and there are people who commented on this article. So there are about 1,000 comments. Okay. Now people comments about various things. Okay. So because this is a general blogs and comments and news comments, this kind of scenario. Okay. Sometimes people comment about general things. So for example, look at this red box. So the comment says that it's good to see mainstream tablets are getting cheaper with better technology. I just got a 10-inch Chinese tablet. So this is nothing to do with the very much review that text. But he has some general comment that he wants to make. Then there are comments which are totally irrelevant, like I don't like to use tablets, I use laptop and mobiles, etc. Okay, so this is not at all related to the main content of the article. Then there are specific comments. These specific comments are very interesting because they are related to the specific information. For example, there is a review article on so this is one of the early stages of retina display, and then some people wanted to comment just on the aspect of retina display. Okay, so this is a very specific information because then people get to know about the specific details of this product. So there are these three types of comments: specific comments, general comments, and irrelevant comments. So where most of the techniques just focus on the general comments and irrelevant comments, but they fail to discover the specific comments. So specific comments are much more informative because they can look into the specific points in the article and they can give some insights and public sentiments, etc. So that I'll come shortly. Look into a different example. So let's look at the public speeches by ex-president Barack Obama. So there are I studied this corpus of 8 years, okay, from 2004 to 2012. In that, there are two speeches at Carnegie Mellon University. Okay? And in the speech, if you look, he has mentioned Carnegie Mellon only a few times. So the Carnegie Mellon is actually very difficult to detect unless until you want to find out whether Barack Obama talked about Carnegie Mellon. It is really difficult to get this information if you use some exploratory tool. There are situations in software. Suppose you want to mine software. So mining software means you want to understand what the software is doing. Now the software codes, they are also can be treated as a text, and there are tokens which can be split into meaningful words. So most of the time, the programmers, the good, who follow good practices, so they will give meaningful names to identifiers like database, stats, etc. Okay, so using these keywords, you can very easily identify what the software is doing. So this is an example from database.java in BerkeleyDB database. Okay. So the softwares have some patterns. So these lines are the statements and the colors denote a defined kind of concern. So what is a concern? So concern means the functionalities or intent of the programmer in the software. So there can be various kind of concerns. So some of the modular concerns which are predominantly present in some file, and there are some cross-cutting concerns which goes across the file, and there are some subtle concerns which are cross-cutting in nature but also not very prominently present in any of the files. But these subtle concerns can be very useful. For example, the statistics, how many times the statistics command have been used, okay? What that software is doing in terms of logging, etc. So those kind of information can be captured through subtle concerns. Okay. So here, for example, here this stats, so it's present in only few lines, but you can understand that whether there any, if you do not know that stats has been used in this kind of software, you will not be able to fetch it because we are working in this exploratory mode. So what is the significance of subtle information? So remember the characteristic is that it is presence in the document as well as corpus is very rare. So by rare I mean the count of the words that represent this information is very less. Now often this subtle information contains precise and specific information, as I was saying, because they are not talking about the general content. But the rareness is what that makes it very challenging. So we are in this context. So what is the challenge? So it is not clear what the user is looking for, right? So we are in the exploratory IR mode, as I said. Then often the outcome is subjective. So it becomes hard to optimize. So what I mean here is that suppose you know that what you are trying to solve, and you have suppose look into the classification problem. You want to classify the words among the sentiment. So you know the tag. So you can easily form a optimization problem and use a neural network to solve it. Okay, but here it is very difficult to optimize because most of the things are sometimes subjective. Then the target information itself is rare. So because in various cases, the subtle information will be very different. For example, you look into the news corpus, it will be different. If you look into the public speeches, it will be different. So in various cases, it will be different, and it will be very difficult to form rules or knowledge bases to solve this problem. So you have to rely to the unsupervised probabilistic methods. Okay. But in that probabilistic method scenario, this rareness makes the statistics insignificant. And most of the standard methods, they rely on this statistics, right? So this prominent statistics actually shadow the rare events. So we'll explore a statistical regime here using Bayesian principles. Okay. Now coming back to this, so this is this challenge of like discovering this subtle cluster. Okay. Now how do you, so this is analogy with the cluster. So how do you find out this significant clusters which are actually getting dominated by some big clusters? Now we are coming into this paradigm of topic modeling. So these topics may be helpful in exploratory IR. So why? Because they do not need any labeled information, or they do not need any target to optimize. Okay. So what is topic? So topic is a distribution over words, and one can interpret this topic as a set or cluster of words. So often topics semantically relate to real concepts. Okay. So for example, I have given the 4 topics here. This is taken from the 20 news group corpus. So top 5 words from each topic is presented here, like good, people, Jesus, Bible, Christian. So if you look into these words, you'll be able to relate to some of the concept in real life. For example, the first one relates to the religion, then second one relates to the Windows system, then third one relates to the cars and bikes, and fourth one relates to the encryption, cryptography, etc. Okay. So just to make sure I'm audible, right? So things going fine?
Yeah, it's fine.
Yeah.
Okay.
Sure.
So topics can help in exploratory IR because if we can discover the meaningful coherent cluster of words from documents, then we are actually extracting the concepts from this set of documents, because these words are present in the documents, right? And these words are everything in the text. So they convey the message basically. And if you can find out the coherent clusters, you get a piece of information. But these concepts often relate to the real world information, right? That is the beauty of the topic model, because you don't have to do anything. You don't have to give any expert information, no label data, but they're somehow magically finding out this information from the document. Right? But we are not giving any direction, instruction, and supervision. Basically, that is what we need. So thus extracting topics in unsupervised manner can help in exploratory IR. Okay? But then now our focus got shifted to detecting subtle topics. Right? If we can detect subtle topics from the corpus, then we can discover subtle information. Right? So I am now linking subtle topics with the subtle information. So now the objective is that how we detect subtle topics from a set of documents. Okay. Now we come back to this basic tool of latent dirichlet allocation. You might be knowing that this is one of the most popular technique in machine learning, and so it has been very widely used in various places. And even now, in case of unsupervised text analysis, this is one of the very useful tool, even after the, very useful advance in the deep learning. Okay. So what is this figure is showing? So look at this shaded block W, which is what we observed. So that is those are my words. So these words are coming from some document. Okay. And what I have these boxes means that some loop or repetition. So for each document, that theta, So I have the number of documents, and each document I have small number of words. So this is the basic setting in the simplified scenario. Okay, and each document has some proportion over this topic. So basically, you want to find out the topics. Okay, so basically, I assume that there is some distribution over the topics for each document. So what it means is that suppose you yourself are trying to write an article, okay, in some news or magazine. So you'll have some topics in mind. For example, it can be about sports, entertainment, movie, or it can be about COVID, etc. Right? So you have some arrangement in your mind that I'll put this much of weightage to the COVID and what is the effect of COVID on outdoor games, etc. Let's say this is your topic. So there is some proportions, right? That is there in your mind and which is represented through theta here. Now, every time you write a word, so that word is W. Before that, you have to decide that which topic you are going to write. It can be about the COVID, it can be about the general pandemic, it can be about the sports, it can be about football, anything, right? So you just pick the topic and just once you pick the topic, the topic is the distribution over the words. Now you know that. So corresponding to each topic, there are different distributions. For example, if the topic is about football, then the high probable words will be goal, football, etc. Right? So then accordingly you pick the word and keep writing. So this is also a generative model because of that. I'll explain that using this figure. So what is topic? So this is the simplex. So suppose I have these 4 topics here, 4 words here. Then topic is one point in this simplex. So I have quarantine, goal, fireworks, cricket, etc. Right? So this blue point is more close to the quarantine. So this topic has very high weight for the quarantine. Maybe it is related to the COVID. Then if there is this green block, then this green block is very close to the goal. Maybe it is the topic related to football. Okay. Then there is some topic vector for each document. Now there are these 4 topics: COVID, cricket, celebration, football, etc. Now this yellow block means this document is more about COVID-19, while this green block means that the topic is about cricket and celebration. So I'm not going. Let's move on. So use this example. So here this is this review article that I was talking about. In that I have all these words. Right now I am giving example of these 2 topics. This blue topic is about the Nexus or tablets, and then green is about phone. Now, you see that I have highlighted some of the words in the article. So this is automatically found using the tool of LDA. Okay, and this bottom left figure is showing the proportion over topics for that document. Okay. So this input is the document, and you want to automatically find out the topics and the proportion over topics for the document. So it's something like this. So I have borrowed this figures from some external source. So the input is some article, and from that I want to find out the topics and the proportion over topics. Now, what is the use of it? These topics are basically cluster of words, so they can be related to some semantic information in the real life. So this can be a source of some hint that what is the topic about in the document, okay, and what are the proportions of those topics in the document. Okay, so let's keep this. Now here there is one small problem that I do not know the number of topics, okay, because I do not know the corpus itself, and that is why I'm applying this unsupervised tool. But it is very much required that I need to specify the number of topics, and that is the problem which we can solve using hierarchical Dirichlet process. Then hierarchical Dirichlet process is a basic non-parametric technique where just keeping all the details. So what it does is that it can automatically find out the number of topics. So you don't have to worry. You just give the corpus as input, it will automatically find out the number of topics as well as the topics. So the problem is solved. But the main challenge here is that this LDA, HDP, and this kind of models, they cannot detect certain topics. So what is the issue? The issue is that the standard models inherently captures prominent topics. And subtle topics are rare and present in a few sentences of the document, so it becomes very difficult for this topic. Moreover, these sentences may not be together in a paragraph, right? This can be scattered all throughout. Maybe suppose this is the article about effect of pandemic on outdoor games, and you're talking about let's say the effect on the children. Maybe you can mention some sentences in the beginning and some sentences in the end, but they together relate to the same topic. Right? So it becomes very difficult for this standard method. So recall that the topic vector captures the overall topic preference of the document. And we have one single topic vector. So it becomes very difficult for these methods to model this diversity across the document. Okay. So most common topics naturally have higher weightage because I have to cover the distribution should be able to justifiable for the entire document. So it should have high weightage for the more prominent topics and should have less weightage for the very rare and subtle topics. And if it is very rare and the probabilities are very small, then it becomes very difficult to capture because it becomes statistically insignificant. Right? So any questions so far?
Yeah, I have one question. So this subtle information, so can we correlate to say named entity recognition in a specific topic, or is it something we are dealing with only the hidden content? So probably the user might have spoken about say CMU for the first time, and in the entire passage he never spoke about the same CMU university. So is our task to identify CMU is the subtle topic, or can we also apply this technique to identify named entities in paragraph?
Okay, so this using subtle topics, we may be able to detect named entities, or rather we say we can apply it for detecting named entities which are subtle in the nature. But in the general problem of subtle topics is that we want to find out any information which is subtle, which may be named entities, which may not be named entities, which may be something else, which may be some topic. I'll show you some examples that you can find out that what Obama talked about the education. Okay, so you'll very rarely know that what Obama was thinking about education, right? So this kind of exploratory analysis. So people might not know that what was, I mean, Obama's. Also, this example that we found that what was the weightage of Obama's speech when he visited Middle East on nuclear deals, or what was his, I mean, stand on the Israel-Palestine issues, etc. So all these minute details, sometimes there are people that who know that what they're looking for, but there will be some people who do not know, and if they can find out, okay, these are, so suppose somebody is reading the newspaper and they do not have much time, and you can just highlight the more important point in some side pan, right? So this, if you apply standard techniques, so they'll miss lots of this minute important information. You can think of this as like a summarization. So if you miss subtle topics, then you'll miss a lot of important information in your summary. You can think of it like that. Whereas, I mean, if you detect the subtle topics, it can relate to many. I mean, it can solve very many exciting problems that I'll show you.
Okay. So I have another question. So we all know that so one is this discriminative kind of modeling of using deep networks, or probably the generative modeling using Bayesian networks. So which one should we choose? And from your past experience, which is better? Because current trend in deep networks, so people are quite inclined to use it because it's very simple and easy to do it. So what is your comment? Like, what are the pros and cons in both the approach?
Okay, this is a very good question. So thing is that so there are advantages, or say there are abilities and inabilities in both the cases. So this deep learning, so if you have a training data and you know what you're looking for, so you know how to form that optimization problem, right? So that is your loss function. Then you can go for the deep learning, because basically deep learning is trying to model a very complex function. And this complex function is something from X to Y. So X is your input, right? Your text, and Y is some tags. It can be named entities, it can be the sentiments, etc. Right? So if you have training data and you know what you're looking for, and you can then learn this function, which is very complex, and neural network is nothing but which is representing this function. But there are scenarios where you do not know that what you're trying to optimize. So you do not know what is your loss function. You do not even have the training data. So you cannot put this into this paradigm. So then you have to resort to the situations where you can do this kind of decision modeling and can do exploratory analysis. So where, I mean, it is possible to apply deep learning, people should try and then see what is happening. But if it is not possible, then there are other classical techniques based on decision paradigm where, I mean, you can get some basic idea. Suppose you are given a big corpus of 10 years collection of some historical archives, let's say. Somebody has given you and they have asked that, tell me that what is this about? I mean, what are the main things and what is the gist, etc. Right? Then, I mean, what will you do? You cannot apply deep learning because this is something has come very much new and there is no experience on this. You do not know even which model will work. You go to the loss function, what you're looking for, etc. Then just throw this kind of topic model and which will give you a very nice summary. Okay, once you understand that, then probably you can find out, okay, then you can hire some people and then ask them to label some of the documents, then build something on LSTM, etc. Those things you can slowly do. I mean, but I mean, this is Bayesian models or topic models just give you this ability to just start from nothing. So that is the beauty of this.
Yeah, sure. And so one last question. So generally when we deal with this generative kind of model, so the underlying data distribution should be understood. So is it the same case here as well?
No, actually not always. So thing is that this underlying data distribution can be very complex in real scenario.
Right.
And what we are trying to do is that we're trying to have some kind of approximate scenario. For example, let's say we're trying to model the wind flow across a ceiling fan, let's say. But the actual distribution might be very complicated, but we can approximate that using Gaussian distribution.
Okay.
So similarly, similarly we can do that for text. So the actual distribution might be very complicated, but we are trying to simplify that using this kind of models, which is very simple. So here one simplification is that I am assuming that the words can be reordered, right? Which is not the real case. Then I may assume that there are no articles prepositions in my document, right? Which I filtered out during the pre-processing step.
Sure.
So all those things, I mean, you can change the model. You can try to add more complexity into the model, and that will actually increase the ability of your distribution. So actually, through this model, in the circles and arrows, basically you are creating your own distribution. And when you're creating your distribution, because there is no standard distribution that can model your problem. So generative model is a technique that allows you to create your own distribution. And then you try to validate whether your assumption was correct or not on some real life data. How you validate? You can use some kind of likelihood test. Okay, so whether I'm getting high likelihood or not. So if I'm getting very high likelihood, then my model is correct. My assumptions are correct. For example, so this model will work for the text, standalone text data. But suppose I have comments along with it. How will I change it? How do I change my distribution? So that is the paradigm of generative model. So you don't have to know from the very beginning what is the exact solution. You can always start with something very basic and just keep changing it. Okay, there are two kind of changes. One is that there are some parameters here that you're trying to tune using some techniques that I'll tell you, that inference and estimation techniques. And there is another kind of change that you change this model itself. You add more circles, you drop some circles, change the structure. So that is the choice of the model. So you can do both the things iteratively and find out which is suitable for your case.
Okay. Sure. Thank you.
Very good question. So I think I'll try to give you more insights on this how I decided to change my model to solve this problem of detecting subtle topics. Maybe that can give you some insight how these things are done. Okay. So then probably you can revisit your question at the end if it is still not clear.
Sure.
But very good question. So basically here I start. So because I said that a single topic vector, which is the standard one, fails to capture. So because this single topic vector is the distribution over the topics for the entire document, right? So this red one is my prominent topic and blue one is my subtle topic, right? So naturally it has to have very high weightage for the red topic because it has to justify the entire document. So how do I detect subtle topics? So this is where this contribution is coming, where we decided that we'll have multiple topic vectors. So let's say one topic vector can focus on one type of topic. So this topic vector 3, you notice that it has very high weightage for the blue topic, which is a subtle topic. Okay. So now this is the, this is a very interesting idea, and which we'll put inside the model. So, but before that, let's understand it in a more clearer fashion. So I have these 3 topics, and this top one is the subtle topic. Okay, and these yellow ones are the actual topic vectors, right? Because my topic is my document is very heterogeneous. It is talking about various things. Okay, so the standard method is that you'll take the average of all of it and put this pink box here, which is close to the prominent topic. But because I have multiple topic vectors, I have the luxury. I can put one topic vector very close to the subtle topic. It will give very high focus to the subtle topic. So that gives me the ability. So now you see that how I'm changing for my purpose. So here I'm modifying the latent Dirichlet allocation. Okay. So the basic structure is there, theta, z, w, beta. This part is corresponding to the LD or latent Dirichlet allocation. But now here I have put multiple thetas. So now J, that is the number of thetas which is greater than 1. And this is the new change. Now if you put multiple thetas, then I have to put one more distribution which is coming from this row. Okay. Now every time you try to write something, first you choose which theta you want. Then you choose the topic and the word. Okay. So this is a change. Now you see that I have added this complexity in my model for a specific scenario because I wanted to solve something and which was not getting solved using standard methods of LDA. So I modified LDA according to my plan, right? So, and then we'll see how good it is, right? Similarly, I extended it for the comments, right? I have the articles and the comments. Now comments, the C is the comment word. Now comments word should depend on the article word, right? It should not be random. If it is random, then it's a noise. Then also we should be able to detect that. So there is some some minute details, but let's think about the good comments, which then the topic of the comment should be driven by the topic of the article word. That is why there is an arrow from Z to Y. Okay. So I have this multiple topic vectors here. I'm choosing the topic to write my article words. Then based on those topics also I'm choosing this comment topics and then writing comment words. Okay. Now forget about all other circles here. That is for the details. But this is actually doing the beautiful thing. Okay. So there are some challenges with MTB also because whenever you have multiple things, then the usual questions are that how many topic vectors we need. Do we need 2, 3, 4, 5, 6, 7, right? So there is no clear answer because we do not know what that corpus is about. Then we have to do something in a very unsupervised manner. But if you use too less number of topics, then many subtle topics will get dominated by the prominent topics. But if you use too many of them, then it will split the document in too many small parts and you'll end up getting too many noisy things. But on the other hand, there are some documents which are more coherent, so we need there is a less chance of subtle topics. But there are some documents which are mix up many concepts, so there will be many subtle topics, right? So how do we deal with this challenge? So to deal with this challenge, we'll bring in this concept of stick breaking process. So before I go into stick breaking process, is there any question on this MTB part? So let me recap it. So the MTB is to solve this problem that because we have one topic vector, so there is one distribution and one distribution fails to capture subtle information. Okay. Now when we bring in MTB into the picture, then the question becomes how many. And to address that how many question, we are bringing in stick breaking process. The stick breaking process is a Bayesian non-parametric prior, and when we're talking about Bayesian non-parametric prior, that means it can learn certain things automatically. Okay, so less number of parameters. So this is the beauty of Bayesian non-parametric. So for example, you look at this clustering scenario here. So there are three situations. Now there are 2 clusters in the first picture, 3 clusters in the second picture, and 4 clusters in the third picture. Now you see that cluster, I think that 2 is doing the correct job, because in the third scenario I am breaking a coherent cluster, but then clustering 1 actually is also not good, because it is dominating, the green cluster is dominating the small cluster. Okay, but how do you correctly identify? If you give input as cluster number 2, K means it will give you clustering 1. If you give K as 4, then it will give you clustering 3. But you may not know what is the right number, right? So that is where this kind of models come useful. It will automatically find out the right number of clusters as well as the clusters. So what is stick breaking process? So the idea is very simple. So you have a unit length stick, okay, and every time you break a fraction of it, you can keep it aside. So here I have broken this fraction V1. Okay, this one is broken. Now from this part is remaining. From this part I am breaking this part. So like that, I keep breaking this stick. Okay. Now notice that each part is a fraction, because I have a unit length stick. So how many times can we break this stick? We can break it infinitely many number of times, because we are always breaking a fraction of what is left, right? And then if you put all the fractions together, you will always get back 1. Okay, so this is giving you this beautiful technique that you can break infinite number of times, which will sum up to 1. Okay, now this is the thing here. So I better skip this and maybe come back if you want to know the details about stick breaking process. But what the idea is, I'll come back to the basic notion. The idea here is that, so the stick breaking process, how it is applied for the multiple topic vectors, how it is choosing the right number of topic vectors, right? We are interested in this part. So suppose I have 1 topic vector, then it is a normal topic model with only theta. Then I have 2 topic vectors. Then I have theta 1 and theta 2. And rho 1 and 1 minus rho 1 is the weight, right? Now if I have 3 topic vectors, then I have theta 1, theta 2, theta 3. So like that, I can have j number of topic vectors, or I can have infinitely many number of topic vectors, right? This is the possibility that stick breaking process is giving. Then I apply Bayes rule. What is Bayes rule? To recap, so I want to know about p of theta given x, which I can find out as this p of theta, then f of x given theta, then p of x. This p of theta is coming from the stick breaking process, and f of x given theta is coming from the data model. What is my text document, right? So we will find out that how many correct theta I need. How? So this is the intuition here. Suppose I have 3 documents, 3 models, M1, M2, M3, which has 1, 2, and 3 number of topic vectors respectively. Okay, and I have 2 documents, D1 and D2. So applying Bayes rule, I want to choose the correct model, right? So I am looking into this expression, probability of mj given di. So for which document, which is my right model? So basically, for which document, which is my right number of topic vectors, right? Now suppose D2 is more heterogeneous than D1. So D2 should have more number of topic vectors than D1, right? So how does this model automatically find out? So what it will do is that it will look into this expression, right? P of M1 given D1, whether it is greater than P of M3 given D1, right? So if it is more coherent, then 1 topic vector should be enough. So P of M1 will be greater than P of M3 given D1. So model 1 will be chosen. That means 1 topic vector will be chosen. Whereas for document D2, the P of M3 will be greater than P of M1 given D2, because it will prefer more number of topic vectors because it is more heterogeneous, right? Now P of Mj is coming from SVP. Now applying Bayes rule, we can automatically find out the right number of topic vectors. So why SVP is useful? Because this allows you to choose any number of topic vectors, but using base rule, you pick the right one. So this is the crux of the story. Any confusion here? This it is not that easy, but yeah. So the idea is that I give the options to the model that it can be 1 or 2 or 3 number of topic vectors. Then I just choose based on the probability that which one is giving higher likelihood. Okay. No, there is no closed form solution. You'll know that because I have complicated my distribution so much, so there is it is not like Gaussian distribution where I can maximize the likelihood. Now I resort to the gift sampling, which is well known in the paradigm of LDA. Okay, but there is this additional complexity due to stick weighting process. But luckily, stick weighting process is proven to be equivalent of generalized Dirichlet distribution, and generalized Dirichlet distribution is also conjugate to multinomial distribution. Now, if you are aware of gift sampling, you know that this gives me a collapse gift sampling technique. I'll skip the details here. But we can extend the gift sampling mechanism of LDA very easily for STM and SCTM technique. So that is the bottom line. Okay. Now let's get into something more exciting. So this is the evaluation. Now, how do you know that my model is good? So I tested on the perplexity. So this perplexity? Perplexity is basically something function of negative log likelihood. So if likelihood is high, then perplexity is low. So lower the value, that means better is my model. So that means how good it is fitting the data. So you see that the proposed model is STM, which is doing much better than all of the standard methods in all data sets. What is the topic coherence? Topic coherence is an interesting thing to check here because I'm splitting my topics, right? So how do we make sure that I'm not getting something noisy? So it is very important to check the topic coherence. So there also it is doing good because the data sets that I have chosen, which has many subtle topics, and the standard methods, they try to find out big topics which are actually not very coherent because they're mixing up many topics together. So that's why coherence is less, and I am getting better coherence. Now this is more interesting that how many subtle topics I have detected. Now this is something that I've done at the back of my model, that I have counted how many subtle topics are there in these data set, and then how many of them are being detected by this model. Okay. So because STM, which is a subtle topic model, is designed for detecting subtle topics, is naturally doing good. But okay, we had to check it. Now this is the example. Now this Obama corpus, we saw that these are some of the topics which are missed by the standard models, but our model could detect it, like cyber security, internet, regulations, infrastructure, employees, Carnegie Mellon, school, students, college. Okay, so all these are very interesting things. So if suppose you are summarizing Obama's speeches using topic model, you will miss all these interesting things, right? So that is very obviously substandard. Similarly, NIPS corpus, right? NIPS is very popular machine learning conference. So you see that even some popular things like supervised classification, topic model, I mean, all these things are missed by standard methods, which we could detect, right? So this is the exciting part. Similarly, we have shown that it can detect more specific comments. So look at this figure at the bottom. So we calculated precision recall and F1, which is much higher than the standard method. Okay. So, but this is like a sanity check. The more exciting thing is here. So this is the article of that Obama's visit to Middle East. Okay. Now you see people. I studied the comments, right, using this model of subtle information, right. Now this is the bottom part. This is the output of the standard model, which is actually one mixed topic of many things. Whereas we could find out many different kind of minute topics like Israel-Palestine peace talk, Iran-Israel nuclear deal, Obama visit expectations, Syria, or okay. And if we find out this kind of detailed topics, then I can highlight the comment, that which comment is talking about what. And I can also highlight the articles, which part of the article is talking about what. Then I can find out the hotspot, which is the part of the article that is being mostly commented. What is people attention? Where is people attention, right? So we can do this kind of microscopic analysis. So I can plot a bar chart that what is the fraction of people talking about what. So this is absolutely not possible using any other standard technique, because for them this is the only output, is gray one. Okay, so I can cover the entire spectrum of users' comment, I mean their sentiments, opinions, etc., whatever you call it. So this gives me also this opportunity for recommendation, because I know that what is that person's interest. Because specific comments give me very good information about the person's interest. Because person will make specific comments only if he is very much interested into that. Others will make general comments, right? If somebody is commenting about Iran nuclear deals, that means he's interested in that comment. Then I can recommend him that, okay, you may like to read about this kind of other news articles, etc. Okay. So this work also got published in Sexis 2015, which is a top-notch conference on recommendation. Then we also extended this work for multiple languages, so which is very, very natural in Indian context. So here the article can be in Hindi or English. So and people can be commenting in any language. They can be commenting in English. They can be commenting mixing Hindi and English. They can be commenting Hindi but in English script, like the last comment, right? Gujarat ki sarkar Gujarat ke layak nahi, etc., etc. Okay. So how do we model this kind of scenario? What then also can we find out what is people's specific interest? Okay. So this also got published in AAA 2015. Then we extended it for fashion. What is people interest in clothing? So what people are trying to wear. So this is very challenging area, because when it comes for dressing, people have very wide variety of choices. Some people like different kind of things. So how do we make good recommendation? So this was one problem around that. Okay. Now I'm coming to end my talk. So in the conclusion, the subtle information are important to be discovered, and subtle information can be found in several places, as I was trying to convince you using my examples. It's generally hard to detect subtle information. That also I convince you, because of this single topic vector standard models are not very capable of doing that, etc. Then we have applied this unsupervised technique. So I like to remind you that I'm not using any level information, any expert information, nothing, right? I've just made some changes in my basic topic model, and is automatically finding out all this, all the examples that I was doing, right? That is the magic. And there are multiple exciting applications. So this is not the end, right? It can be applied on various other things, and we are still exploring that. Okay. So I have some more things to say, but this is more or less my talk is over. But if I'll try to take some questions or feedbacks now.
So thank you very much for a very nice talk. Is it like one of the thing I was thinking particularly while listening to the examples? So there are cases when the document has certain things, but when I want to extract the information, we want to retrieve the information asked in a different way. For example, a document is having say Carnegie Mellon University, but the query is related to CMU. So, and CMU is Carnegie Mellon University is difficult to understand if not known. So how those things can be handled if I have to design a system like this?
Yes, because so what is happening is that so these topic models are clustering the word. Okay, so I'll try to. Are you able to see my drawing here on the site?
Yes.
Yeah.
You are able to see.
Now suppose these are my documents, okay, and here I have some of the words. Now what this is going as input to my topic model, and the output is my topics. Now this topics is nothing but cluster of words, right? But how this cluster is happening is that so it is looking into the co-occurrence of the word. Okay, it's looking into the co-occurrence of the word. Now suppose Carnegie Mellon University, somebody writes, then most likely he will put a bracket and write CMU, right? and that will happen across multiple documents. That means CMU and Carnegie Mellon University are co-occurring together across multiple documents. Then topic model should be able to capture that. So this is called co-occurrence. It looks into the co-occurrence.
Okay.
So through that we can put a mapping. So it should be able to detect that CMU and Carnegie Mellon University, they are same. It may not be able to tell you that they are exactly same, but it can tell that they are related.
I see. Is it possible to somehow this is kind of a world knowledge that people call CMU as Carnegie Mellon University. So assume that is not there. Is it possible to integrate some kind of an information base or knowledge base to enhance this?
Yes, very good question, and that is very much possible. So thing is that, so in my model, what I can do is that I can put some constraint. The constraint is that suppose I have WordNet in my hand, and I'll tell that, okay, these words mean same thing. So whenever you see CMU, you relate to the word Carnegie Mellon. Something like that I can do. So if that expert information I can feed. Now I can feed other expert information also. For example, suppose I have set of tweets, okay, from the Twitter I've got. And in Twitter, I have this additional information of hashtags. Now it is very pity that if I throw away the hashtags because they are very informative, right? So we can put some extra advantage through this hashtag. So all these modifications are very much possible in the topic model.
Okay, I see.
So then we can do that in case of multiple language also. Suppose I have multiple dictionaries. Okay. So if you remember my example of this multilingual work, right? So you see that it is connected these topics: politics, leader, state, neta, rajniti, rajya, sarkar, neta, dharm. Okay. So how it did? See, this is not a basic LDA. So I have made some modification. I have put some multilingual concept inside this topic model, which is able to find out this connection.
I see.
So that is also possible. And if we have a dictionary, we can make it even finer. I did not assume any dictionary here, by the way, but we used Wikipedia because Wikipedia has linked articles. So some English articles has corresponding Hindi articles, right? So we use Wikipedia linkage here. So some kind of bridge you have to use across language, which can be dictionary, which can be Wikipedia, which can be WordNet or etc. But more information you feed, you can get finer results. But less information you feed, you'll get at least something. It will not be zero. So that is the beauty of this model.
I see. Okay. Yeah, nice. Thank you.
So I have one query. So this math, can you please revisit the mathematical equation? So if we want to actually implement it, so what all we need to consider?
Yeah, I'm just going. You just asked me to stop. Here.
Yeah.
Yeah, so this part I skipped actually. So let me explain first. So this stick-breaking process actually not my idea. It's just proposed in 2001 by Swan and James in JASA. So the idea is that P is a distribution. Okay, so it is a distribution, and this theta. So what is the notation here? So notation here is little bit complicated. So this notation means theta j delta beta j means probability of beta j is theta j. Okay. Now what is P? P is a distribution over this beta j. So beta j's are called atoms because you can think of these are like discrete points in my space. And I'm putting some mass on each of these discrete atoms. So you can think of it like this. Some discrete atoms are there on my space and I'm putting some weightage, some mass. Okay. And I have infinite number of them. And this weight will sum up to 1. And why it should sum up to 1? So here it is summing up to 1, this weight, because of the stick-breaking process. Okay. But it is allowing me to have infinite number of beta. So these atoms. Now these atoms, okay, this can be topics. So I can have infinite number of topics. It can be topic vectors. I can have infinite number of topic vectors. But okay, Then, so this is just the prior information because I have not seen the data yet. Now, when I see the data, then I apply this Bayes rule. Okay. Then I come to this model selection, which will be good. So this P of MJ, this is coming from SBP, which is allowing me infinite possibilities. But then I check which model is giving me higher likelihood, higher probability. Based on that, I can choose. So you are asking that how I am implementing it, right?
Yeah. So this part. Yeah.
Yes. So implementing SBP involves this expression. So these are coming from beta distribution, and so basically I am not implementing to be clear that I am not directly implementing this because there are various issues that I was telling you that all these things. So I have to. So what ultimately I have not put the equation here. I'm sorry, but actually ultimately the equation looks very simple because of doing all this mathematics, which is actually like sampling one more discrete random variable like B, which is coming from some distribution. It's a calligraphic P, and how I'm getting this calligraphic P? So that is applying this mathematical tool, but which is very simple. But at the back of it, I have this Bayes rule and the Stigler's process. So what I have, so if you remember that in LDA, I have this variable Z I have to sample from some distribution F. Now I need to sample only one more random variable here, which is B. Then I just iterate over it. That's it. The actual code is very simple.
Okay.
I don't know if I could give you the entire thing, but I mean we actually can really go into details and discuss. I'm very happy to hear your question.
Sure. So I understood quite a fair amount of the implementation, but I still have some doubt. But we can probably discuss offline once I.
Yeah. So what you can do, definitely you write to me. You can also look into my ICML 2013 paper, which actually has the mathematical details. In later parts, I dropped that because I always refer to that paper, but the basic equations can be found there.
Sure, I'll do that.
Sure.
Okay, so let's wait for some more questions, probably from other participants.
Yeah, one of the question is from me. So as Ranjan has pointed out some of the questions, our area of work is little different, but topic modeling can help us. So is there any references, or we haven't worked on topic modeling in details like with the clarity what you have explained? So where we can look into this kind of work, particularly to find the subtle information, GitHubs or something we can.
Subtle information, if you need to know, then you have to talk to me. Actually, that nobody else has done.
Okay.
I mean, there are some works after me, but this is the topic that I started, and this was one of my contribution in my thesis also. But if you are really interested in topic model, there are various tutorials because it's one of the most popular thing in entire machine learning literature. If you see, but I will say that if you look into the Blay gave a tutorial, David Blay, who is actually the father of topic model. So it is there in YouTube. It's about 1 hour lecture or 2 hours. I don't remember. I can surely email you the link.
Okay, thank you.
But he is generally the authority.
Okay. I'll note it down.
Yeah, I don't remember the link, but it is there. But I have not listened to that.
You do not need what we need actually.
Sure.
You have done all research on this.
He is very good.
I see. Thank you. Ranjan, I am done from my side. If others have any questions, you can check.
Okay, let me just check the chat. So there are no more questions. I believe we can move to the next topic. So thank you, Dr. For the tech.
No. But I spare me 2 minutes. I want to advertise myself here because I got this opportunity. So these are some of the research areas that I am really working actively, like Bayesian models and unsupervised text analytics and private share learning. So I'm very much actively working in this. I also have a funded project in that. Causal analysis is something I'm really starting recently, and smart and precise agriculture is my new hobby, and we have a big funding for that and slowly moving into that. And creates, actually, Ranjan has talked about it. We have established Center for Research and Education in Data Science, creates, and which has many activities, and the smart and precise agriculture is one of the focus area in that. Then we also have started a MTech in data science under the trade, where this is a truly unique program because I mean, you'll not find any data science program where you can, I mean, people from civil engineering or instrumentation, they can apply, right? So, but we are accepting people from all backgrounds, even people from physics have also applied, and they'll I mean, with any UG degree you come in, and with a PG degree in data science you go out. That is the motto. So, and we are also actively hiring for MS PhD and research associates for this smart agriculture and also other fields which are interested. I'm co-organizing a workshop in PhD the coming year on smart and precise agriculture. Please do consider to submit your papers. You can learn more about in my website, which is here, and you can also, I mean, find out the case website. And please feel free to drop me an email if you are willing to collaborate with me or to talk about anything. Okay, anything related to machine learning, I'm happy to answer. Okay, so that's it from my side. Thank you.
Sure. Thank you, Dr. Ranjan. So it was a wonderful tech talk on subtle information modeling. And I believe it is very, very challenging NLP task. And so understanding this will definitely help us in designing various systems like Q&A. So we'll definitely look into your paper as well as other topics related to this subtle as well as topic modeling. So thank you, Dr. Minal, again.
Thank you.
So moving on to the next topic. So it will be our paper presentation on the topic known as a character representation enhanced on device intent classification. So over to the author to share the screen and start the presentation.
Yeah, thank you, Ranjan.
Yeah, please go ahead.
I'll share my screen now.
Sure. Yeah, it's visible. You can go ahead.
Thanks for the confirmation, Ranjan. Good afternoon, everyone. I'm Sudeep from On-Device AI group of Samsung Research Bangalore. And today I'll be presenting our work on on-device intent classification. First of all, thanks to the ICON working committee for giving us a chance to present our work. So let's begin. So intent classification is the task of identifying the intention behind the user input. It's the task of, like, you have to understand what user wants when it gives you the input utterance. Intent classification is an important task in all natural understanding systems. These days, if you have interacted with the customer service, you'll first have to interact with the chatbot who will understand your intention, and based on that will try to either resolve your query or will uh, will you lead to the customer service representatives. Similar way, the intelligent virtual assistants, the use of intelligent virtual assistants is on rise. And as Siddhartha has beautifully explained in the beginning, uh, how intent classification plays a crucial role so that NLU system can understand what user wants and give an appropriate response. Now, there are huge number of intents which are possible. So therefore, intent classification is usually domain specific. There is a predefined set of intent labels which our model is supposed to identify. So for each of the given input utterance, you have to assign a categorical intent label from the predefined set. Now let's see why on-device intent classification is significant. Most of the NLU systems these days are cloud-based, but If you have an NLU system which is on device, offline interactions are possible. There will be no need for internet connectivity. You'll have the system at your exposure anytime you want. Since your data will not leave your device, there will be no privacy or security related concerns. Your model will be working on device. Therefore, there is no need to worry about no internet connectivity or low internet connectivity. It's reliable. Now you don't have to send the data to a cloud, receive response. So this time is, we save this time and therefore we get the faster processing. There are other many advantages that on-device NLU system has to offer. Now, if you want your intent classification model to work on a device, a resource constrained device, it should have a tiny memory footprint. It should have a low inference time in order of milliseconds, and of course it should be accurate. So let me give you an overview of the architecture that we've used to serve this purpose. We'll discuss about each and every component in detail in later slides. We've used the character representation of a word along with word embeddings to get enriched word level representation. We've used LSTM as encoder, and for the classifier part, we've used fully connected layer with softmax activation. Now let's take a look at components one by one. Now, why do we need character features of a word? Let's say that we use only word embeddings for our model. In that case, since we have memory constraints, it's an on device, it's going to run on device, we have to limit the size of the vocabulary. Because if you don't limit the size of your vocabulary, your read-only memory, like the model size will be in order of hundreds of MBs, which is not which is like really not good for your model if you want to infer it on device. So if you limit your vocabulary size, you need a mechanism to get the representation for the words which are out of vocabulary. This is where character features of a word play an important role. It helps to get, since we are getting the representation from the characters, we can build representation for any word irrespective of it's in a vocab or not. Also, it has advantages like getting similar representation for the word with common prefix or roots. So let's say the rare petrify is a rare verb and it's in our vocab and our model knows how to build the representation for petrify using its characters. The same way model can build a similar representation for petrifies and petrifies which have different suffixes, but the root is common. Therefore, our model will our model will build a similar representation for it. Also, because of this, we don't need to worry about spelling mistakes as we'll be using the same combination of characters, even if you misspell a word. Now let's take a look at the architecture that we used for this purpose. We convert the characters of a word into character embeddings. We feed it to the 3 convolution layers with different parameters, with different convolution windows. Output of the convolution layer will be max pooled. This helps, having multiple convolution layers helps to capture the different n-gram features of the word. We concatenate these features to get the final character level representation of a word. I'll illustrate this method with an example. Here's the word demonetization. We have the character embeddings for each of the character. We perform the convolutions with different parameters like this, get the max pool, perform the max pooling operation and capture different n-gram features, finally concatenate them to get the final character level representation of the word. We need word level. We also need the word embeddings because they capture the semantic representation of a word. We use pre-trained word embeddings for that and fine-tune them for a specific task. Now, since pre-trained word embeddings are trained on a huge corpus, they already have the contextual information, which is further fine-tuned. This helps our model to converge quickly and results in lower training time. So to get the final word level representation, we concatenate word embeddings with character level representation of a word. To sum it all together, here's an illustration of our architecture. For an n-word input utterance, We obtain the character representation for each word and its word embedding. We concatenate them, pass them through an LSTM layer. LSTM reads the input in the forward direction and accumulates rich semantic information. As the last word passes through LSTM, the hidden layer stores the representation for the entire input sequence. This representation will be used to classify amongst the predefined set of intent labels. We use a fully connected layer followed by softmax activation for that. Let's discuss about the datasets that we've used in our work. We've used two types of the datasets, benchmark datasets and a custom dataset. We use benchmark datasets so that we'll be able to compare the performance of our model with the existing work. For that, we've used two benchmark datasets, ATIS and SNPs. ATIS dataset is a widely used, most popular public dataset for intent classification and slot filling. It has the audio recordings of the flight reservations. Another dataset is the SNPs dataset, which is collected by the SNPs voice assistant. As compared to ATIS, SNPs is more complex as it has a larger vocabulary and multi-domain intents. ATIS only has intents related to the air traffic, and therefore it has low vocabulary as compared to SNPs. Now let's discuss about the custom dataset. We curated the custom dataset because we want to check the performance of our model on the short and informal text. For that, for creation of the initial data, we've used a user trial of more than 50 participants, and we've scraped web pages for that also. We had decided 10 categories, 10 intent labels, and we've used data augmentation techniques like transformer based data augmentation and synonym replacement to further enlarge the data. In transformer based data augmentation technique, we fine tune a pre-trained BERT model using the initial data. After that, we have a huge unlabeled informal corpus, and this fine-tuned BERT model is used to make prediction on those on that corpus. The high confidence predictions are verified and then used for synonym replacement. In synonym replacement, we randomly replace 30% of the words with their synonyms. For the creation of the test data, we've used another user trial so that their data distribution of train and test are not from same. This is the final data distribution as you can see in the figure. Although data augmentation techniques have helped a lot, and in the end we have a huge number of data, but we've used only 50K sentences per category, and we've also limited the word vocabulary to 12K. Let's talk about the frameworks that we've used for on-device deployment. We've built all our models using TensorFlow framework. Later, we converted our models into the TF-Lite format. This is because the size of the supporting library for TensorFlow is more than 30 MBs, whereas this size of the library needed for TensorFlow, a TF-Lite is less than 5 MB. We've also used post-training full integer quantization, which has helped us to reduce the size of our model by 75%. Let's discuss about the experimental results. We've used 3 data sets. On ATIS, we've achieved an accuracy of 99.53%. Similarly, on SNPs, we've achieved an accuracy of 98.95%. And on custom dataset, we've achieved an accuracy of 98%. Let's compare the performance of our model with the existing approaches. As you can see in the chart, on the ATIS dataset, our model outperforms all the existing baselines. It even outperforms the current state of the art, which is stack propagation framework plus BERT, by more than 2%. On SNPs datasets, our model achieves results comparable to the state of the art and outperforms all other baselines. It is worth mentioning that a number of parameters in our model is less than 1 million, whereas in state of the art, the pre-trained BERT alone uses 110 million parameters. We've also measured the system-specific metrics on the benchmark datasets. As you can see, the model size on both the datasets is less than 1 MB. Also, the inference time is less than 2 milliseconds. We have a tiny memory footprint of 5 MB for both the datasets. So to conclude, we have proposed an architecture for on-device intent classification, which has a tiny memory footprint, which has a very low inference time, and of course it's accurate as it's known from the fact that it achieves state-of-the-art results on benchmark datasets. So for the future, we want to use this approach and develop a joint model for intent classification and slot filling, and also experiment with the thin versions of the BERT like tiny BERT, distal BERT, etc. Yeah, that would be the, yeah, thank you. Now
Okay.
I'll be happy to take any questions if anyone has.
So Sudeep, in your model, so how do you handle this various inflection of the root word, or do you treat them as different words altogether?
We treat them as different words, but since they'll be having a common root, the representation we get from uh, character features will be similar.
Okay.
We do not perform any stemming or lemmatization on our before in pre-processing.
Sure. So, like, did you use any other kind of techniques to reduce the vocab size, or you just took the standard vocabs from some pre-trained model?
We've used the pre-trained glove embeddings, and we've only used for benchmark dataset we've used all the words in the training data, but for the custom model we've limited the vocab size to 12K most frequent words.
Okay. And so for the missing word, how do you represent it? Is it with Ankh?
Yes. For an unknown word, the word embedding will give a UNK token, unknown token, but we'll be able to build a representation for unknown words using character features. That is the main purpose of incorporating this character features.
Okay. Okay, so let me just check if there are any other questions.
Yeah, sure.
Yeah, so Siddhartha has posted a question like, can you please explain the custom data a bit more?
Okay. So for the custom, is it particularly about the like curation, data augmentation techniques, or may I know is he wants to know anything in specific?
Basically, what kind of data it is, what kind of data, and the kind of details of the data also, how you curated and all that.
What kind of learning did you do on that data? Yeah.
Actually, we had a user trial for this. We had already predefined the set of the intents that are visible on my screen. Yeah, here, like wish, invitation, announcement, and all. So we've asked the users if they want to express an intent to wish someone, what is the wording, what is the utterance that they'll be using. So this way we've curated the data for some of the categories, and for some categories like selling and all, we've scraped some of the web pages and collected the data. But this initial data that we got from this was very less, a few thousand, which is not sufficient for a data hungry neural network. So we had to use some data augmentation techniques. So we had used two techniques. First one was the transformer based data augmentation, and the second was synonym replacement. Let me go through them one by one. In transformer based data augmentation technique, we fine-tuned a pre-trained BERT model on the initial data that we've got. We had a huge unlabeled informal corpus. We used it. We made we used this BERT fine-tuned BERT model to make predictions on that informal corpus, and we selected the high confident predictions. We verified them so that there are no mismatches, and this data was further used. We processed the data by synonym replacement, where we randomly replace 30% of the words in a sentence. So in the end, we obtained a large data as it is visible from the pie chart. And for the test set, we used a different user trial. We did not perform any data augmentation techniques on that test set. However, when for training, we only used 50,000 sentences per category, and we also limited the word vocab size to 12K. Although the number of the vocab size of this data was more than 1 lakh something.
How
And
did you
for
choose? Yeah, I'm sorry. Please go ahead.
No, Siddharth, you can please go ahead and ask your question.
Yeah. So actually, the question is, how did you choose from an utterance or from a sentence, which particular word to be replaced with synonym, and what is the source of your synonym?
We've used WordNet for this thing.
WordNet. Okay.
And we've randomly chosen these 30% of the words in a sentence and replaced it. There was no other thing involved. It was random.
Random. Okay. So thank you. I got the answer.
Okay, so thanks, Sudeep. And I hope there isn't any more questions. So I believe that brings us to the end of the workshop proceedings. The sessions that we saw from Siddharth, from Praveen, and from Dr. Mrinal. So all these sessions, and inclusive of all this paper, I believe they were quite detailed and very knowledgeable. I hope everyone enjoyed today's session. And just to have a quick recap, to estimate what is our takeaway from this workshop. So let me just walk through from each of the presentations. So session from Siddhartha Mukherjee, he probably showed us how the NLP trend is moving from unimodality to multimodality. And the panel discussion moderated by Praveen guides us how AI will evolve in future and what are the corresponding challenges that probably we need to address. Okay, and apart from this, I believe the tech talk by Dr. Mrinal was quite challenging problem statement, which justifies that so Bayesian networks cannot be ignored, even though we have achieved other state-of-the-art deep networks. And apart from that, the submitted workshop papers were quite very interesting and showed the diversity of NLP research topics that for conversational AI. Now, to summarize, I believe the key takeaway from all the talks is the final direction to our next scope of research work in NLP and AI. Okay, so and now coming to all those accepted papers. Now, the organizing committee have discussed and finalized that all the accepted papers for this workshop will be issued a digital certificate, and the same will be mailed to all the authors. Okay, and finally, on behalf of the ICON workshop organizing committee, I would like to thank the ICON conference committee, specifically Dr. Asif Iqbal and Somitra, for extending their support in organizing the workshop. And they have been very, very helpful in addressing all our queries, concerns, and helping us to sort our issues. I also would like to thank the Tech Talk and panel discussion experts for providing deeper insights on NLP and AI. And I also thank the authors who participated and submitted papers into this workshop. And finally, I thank to all the program committee members from both from internal to Samsung Bangalore, SRIB, as well as Samsung headquarters, Suwon, Korea, and other national and international academics for helping us in reviewing the paper that are submitted into the conference, into the workshop. And finally, thank you everyone for attending this workshop, and have a nice evening. Thank you.
Thank you, everyone. Thank you, Ranjan. Bye-bye.
Thank you. Bye.